Good morning, everyone. Today, you're going to learn more about the post after an accident. How do you analyze the cause of accidents and find the cause of accidents? Now, on the agenda, it says that I'm doing the afternoon, and that was only because we were still organizing who was going to do it. And one of the people is a pilot and wasn't sure his schedule would allow him to do it, but he does. So we have actually two people. I'm going to do sort of less techy, more social things this morning because we have a management. It's so important in accident analysis. But in the afternoon, Shem Malmquist, and who teaches at Florida Institute of Technology and is a working pilot, and a student at MIT, a PhD student, almost finished with his degree, Lawrence Wong, who's been doing a lot with CAST, are going to actually lead the exercise session. So if you're getting tired of hearing me, you get to hear somebody else. All right. So I think I told you some of this, a couple of slides are repeats. I've done a lot of accident investigation, and this is where I got so interested in it. And I've read lots of accident reports. And one of the things that it seems to me we're not learning enough from accidents. And before, I always tell my students, and I always like to do, first try and understand what the problem is before trying to come up with a solution. And so what are some of the common problems? Well, there's root cause deduction, which I mentioned on Monday, and it'll come out, I'll mention it quickly again today. An oversimplification of the causes of accidents. There's hindsight bias, which we're going to spend some time on because it really is dysfunctional and in terms of accident analysis. A focus on blame, a narrow view of human error, and using inadequate models of accident causality. So let me just mention this again. I said this was a term that came, a colleague at MIT, Professor John Carroll, came up with, called root cause deduction. And the thing is, people like having a root cause because it gives us an illusion of control. If there's just one root cause or two, or hopefully maximum three, and it's all things at the lower levels of the control structure, then there's something we can do. And then we feel like we're in control. We usually focus then, because of that, on operator error or technical failures, ignore the systemic and management factors, but that leads to a sophisticated whack-a-mole game where we fix the symptoms, but not the process that led to those symptoms. And so what we end up being in continual firefighting mode and having the same accident over and over again. When I was investigating a refinery explosion once on a team that was writing an accident report for it, and it was a very large oil company. So I went and visited a lot of the different their refineries to see how they were being run in general. And I visited a very large refinery, and the system safety people asked to meet with me, and so I said sure. And they asked me an interesting question. They said, well, you know, we have several hundred incidents and accidents a year at the refinery. How do we know which ones we should investigate? Because we don't have the resources to investigate all of them. And I said, well, I don't think they liked this answer, by the way. I said, well, you know, you're asking the wrong question, because if you investigated a few of them in more depth, you wouldn't have several hundred of them a year. They didn't seem very pleased with that answer, but that's really the answer. We're having the same thing over and over again. We're blaming symptoms and not the real problems, and the same problems keep causing accidents with different symptoms. And we tend, and related to this is oversimplification of causes. In almost every accident, loss, there's operator so-called error, and we're going to talk more about that, flawed management decision-making, flaws in the physical design of the equipment, safety culture problems, regulatory deficiencies, and basic flaws throughout the whole safety control structure. And if we ignore, and they're there, but we only look at usually operator error and focus on that, or flaws in the physical design of the equipment, and we ignore all the other things, so we never fix them. But they're in every accident. They're there. Jerome Lederer was known as Mr. Aviation Safety. He's an incredible man, a real hero, who actually started aviation safety back in the 1920s with the U.S. Postal Service. And he helped, he was instrumental in starting the NTSB in the U.S. He contributed to the start of the FAA. He, after the Apollo launch fire in 1967, he went to NASA and started their safety program. An amazing man. And he wrote the following: system safety covers the total spectrum of risk management. It goes beyond the hardware and associated procedures of system safety engineering. It involves attitude and motivation of designers and production people, employee management rapport, the relation of industrial associations among themselves and with the government, human factors in supervision, quality control, the interests and attitudes of top management, the effects of the legal system on accident investigations and exchange of information, the certification of workers, political considerations, research, public sentiment, and probably more. But these are the non-technical but vital influences on the attainment of an acceptable level of risk control. These non-technical aspects of system safety cannot be ignored. And some of the people this morning were saying in the first question we had on Slido was, what's the biggest problem? And they said management, and management acceptance of doing things new. Now I want to say a few words about hindsight bias, because hindsight bias is one of the biggest problems I see in accident reports. This little cartoon was either Sidney Decker or Richard Cook came up with this originally. I want to give them credit, but both of them are not sure who did it first. But before the mishap, everything's very complex. You know, all this stuff happening is not clear at all. And then all of a sudden you have a mishap, and afterwards it's very clear what happened. And you see hindsight bias is easy to, usually easy to spot. Sometimes it can be harder to spot in accident reports, because you see words like should have, if they could have, if they would only have. And that's all hindsight bias. After the fact, it's really easy to see what was important. At the time, you've got all this stuff coming in, and without the benefit of hindsight, you can't. It's impossible to determine what was important. Here's another one from that Cali accident. I mentioned the Boeing 757 in Cali, Colombia. It ran into a mountain while landing. The failure of course, flight crew. The failure of the flight crew to discontinue the approach into Cali, despite numerous cues alerting them of the inadvisability of continuing the approach. Those cues were only apparent after the fact. At the time, it wasn't apparent. So it doesn't help to use hindsight bias and say, well, the crew's guilty because they didn't notice these things that they should, that only could be noticed after the fact. There's another one. This is from a refinery accident report. The board operator should have noticed the rising fluid levels in the tank. There is a tank, and the tank overflowed. Now, it turns out that there was the high level alarm, there was an alarm on the tank, but it hadn't been working for 18 months and nobody had fixed it. And it's not even clear that the operators knew it wasn't working. Um, the flow meter, which is the only way they had to show that what fluid was going in the tank, showed that there was no flow. And in fact, in the accident report afterwards, they couldn't figure out why the flow was happening. So they had months to figure out, sit and look at this thing and try and figure it out. And they expected the operators to have noticed, somehow figured this with no clues and no information at the time it was happening. And it turned out at the same time, there was a serious alarm, a potentially serious alarm in another part of the plant that they went and looked at and handled. Why would they spend more time on this thing that doesn't have any clues that there's a problem until after the problem occurred, and ignore the alarm that they were getting? I mean, it doesn't make any sense. So after an accident, as I say, it's easy to see what people did wrong, what they should have done. It's easy to judge about missing a piece of information that turned out to be critical when they're getting dozens of pieces of information all the time. And it's almost impossible. It's really interesting. Psychologists have looked at this, and it's almost impossible to go back and understand how the world looked to someone without the knowledge of the outcome. Once we see the outcome and we've got those connections in our brain, we can't disconnect them. We say, of course they should have known that. So how do we get rid of hindsight bias? Well, Sidney Dekker has spent a lot of time on this, and I really like what he suggests, and we're going to see. I introduced it, put it into CAS. We need to change the way we write and look at accident reports and accidents. We should not be focusing on what people did wrong. It doesn't help. It's all hindsight bias. Think of it this way. Nobody comes to work or gets up in the morning and says, oh, good, I'm going to fly a plane. I'm going to kill 300 people today. That's not what people do. I mean, everybody is trying to do the right thing. And most of the time, we have people who are pretty skilled and trained, even with untrained people. What we need to look at is not what they did wrong, but why did it make sense for them to do what they did? There's some reason they did what they did, which in hindsight may look stupid to us, but at the time didn't look stupid to them. So we need to understand why it made sense for them to do it. Then we can figure out how to fix it. If it was that the alert was not salient, and they missed it, the feedback was vague, there could be all kinds of reasons why it made sense for them to do what they did. And then we can fix the problem. If you just said they should have done such and such, all you've done is figured out who to blame for the accident, but you haven't learned anything about how to fix it. So I talked about this on Monday, so I'm going to go quickly through it for people who weren't here on Monday. Do operators really cause most accidents? Because we've all been told them. Yes, there's an assumption that operator errors that cause the most incidents and accidents. In the accident reports, they all blame it on the operator. So obviously they cause most accidents. So what's the solution? Well, if you don't know why they did what they did and why it made sense, again, if you only look at what they did wrong, what you end up with is you have to do something about the operator. And if they lived through the accident, then you can fire them or retrain operators or whatever, or do something about operators and generalize, marginalize them by putting in more automation, or rigidify their work by creating more rules and procedures, which they're not going to be able to follow because they can't get their work done if they follow them, and then we blame them when they don't follow them. It's a circular argument. It doesn't help. And I showed you this before. All behavior, human behavior, is controlled and is affected by the context in which it occurs. We don't think of that. We think we're in total control. We aren't. We are influenced by the context that we find ourselves, the design of the overall system in which we find ourselves. So a systems view of accidents says that operative error is a symptom, not a cause, that all behavior is affected by the context or the system in which it occurs. And the role of operators is changing as we add more computers and other things in high technology. Operators now are more supervising and systems and supervising computers rather than directly controlling. We put a computer and we put all kinds of automation between the operator and the thing it's operating. They're operating. And systems are stretching the limits of comprehensibility. One of the great studies Earl Weiner did was go into cockpits and just record what pilots were saying. This was fairly old, but I think it still happens a fair amount. And pilots are saying, "What's it doing? Why is it doing that? How do I get it to do what I do?" People were really confused by automation, including me. So we're designing systems in which operator error is inevitable, and then we blame the accidents on the operators rather than the designers. So to do something about error, we need to look at the system in which people work, the design of the equipment, the usefulness of the procedures, the existence of goal conflicts and production pressures, and so on. Bottom line, which is it at first sounds like a very strange conclusion, human error is a symptom of a system that needs to be redesigned. Human error is not a symptom of redesigning humans, which we can't do, or punishing humans, or giving them more procedures that they can't follow, or whatever. Human error, if it occurs, says that we need to redesign the system. That's how we change behavior. And you saw that example on Monday. I won't go through it again. Blame is the enemy of safety. Most accident reports focus on blame. They want to find someone to blame, and usually a person, and usually someone hopefully low on the totem pole of power. The goal of the courts is to establish blame. That is not the goal of engineering. The problem is what happens when you have blame. Well, first of all, people stop reporting errors. So while there's still, one of the reasons I said there's lots of precursors of accidents, but people are afraid to report, hey, I made this mistake, because they're going to be blamed for it. And that's why the anonymous reporting systems have been so effective. Information is hidden even after the accident. Learning is inhibited. It's always point at somebody else. After the accident, it's very hard to get the true story from people because who wants to be blamed for it? So they're gonna slant the way they describe what their role is, especially, and what the role of other, and make more important the role of other people. So courts establish blame. Courts establish liability. The goal of engineers is to understand why accidents occur in order to prevent them. It's not our role to figure out who's to blame. It's our role to understand why, and the reason we do that is we want to prevent them in the future. So here's an example. This is actually an example from an old paper. I went and looked at some archives of someone who's one of my great heroes, Chuck Miller, along with Jerry Lederer. And this is an example they used at an ICASI conference, an accident investigation conference a long time ago. So if this is the way you look at the information, then you're going to get certain kinds of results. So, for example, who? Well, the NTSB in this accident determined the probable cause was the flight crew's failure to use engine anti-icing during ground operations and takeoff, their decision to take off with snow ice on the airfoil surfaces of the aircraft, and the captain's failure to, you keep seeing this word failure, I'm going to come back to this, the captain's failure to reject takeoff during early stage when his attention was called to the anomalous engine instrument reading. Now, in the report, there were contributing factors which were supposed to be explaining why, and they were prolonged ground delay between de-icing and receipt of the air traffic control clearance, during which the airplane was exposed to continual precipitation, the known inherent pitch-up characteristics of the Boeing 737 aircraft when the leading edge is contaminated with even small amounts of snow and ice, and the limited experience, we're back to the flight crew in jet transport operations. Now, we're going to have a poll here about what was the cause. Reading that, and I'll leave it up for you so you can see it. John, can you show poll number 1? We're not going to use Slido for the polls because it's hard for me to figure out where the answers are. I put down everything that had been mentioned.
The poll is running, just to confirm, Nancy. Lots of people still adding answers.
The what?
Lots of people are still submitting answers, it looks like.
Oh, okay, good. Let's show them. Because it isn't very hard to do. All right, interesting. Well, I think that a lot of you have the right attitude. Maybe we're doing this with the wrong audience, because most of the blame, it seems to me here, is on the flight crew. But some people did pick up on the design of the aircraft, and some people thought it was something else that wasn't even mentioned. Interesting. All right. Now, let's go on. One of the things is the use of the word failure in this thing. You notice that we talk about the flight crew's failure, the captain's failure. Failure is a pejorative word. The last time I gave this talk, I had some people in the audience, they said that was their new word for the day, pejorative. Pejorative means it's a judgment. It assigns blame. So when you write the captain's failure to reject the takeoff during early stage when his attention was called to the anomalous engine reading, there's not, blame's already been solved. The captain failed. That's an assignment of blame. We've already made a conclusion that what the captain did was a failure. And so you can sort of stop there, because it's a statement, because we've just concluded. Now, what if we'd written it differently? That same thing, but we wrote, the captain did not reject the takeoff during the early stage when his attention was called to anomalous engine instrument reading. Now, I claim and believe that this sets up a different mental model for people. The first thing is, now all of a sudden I'm spending a lot more time looking at, well, why did he not reject it? And wait a minute, what about those anomalous engine instrument readings? Why did they occur? And what role did they have to play in here? But the first one sort of says, we've already finished. It was a captain's failure. We're done. This is what Miller and others have called and the accusatory approach to accident analysis, a focus on who was responsible. Let's look at a different description of that same accident. And now instead of looking at focusing on who, it focuses on what. Based on the available evidence, the accident board concludes that a thrust deficiency in both engines in combination with contaminated wings critically reduced the aircraft's takeoff performance, resulting in a collision with obstacles in the flight path shortly after liftoff. Notice there's nothing here that talks about who is responsible. It's purely describing factually what happened. There was a thrust deficiency, there were contaminated wings. Those two together critically reduced the aircraft's takeoff performance, resulting in a collision. So now we can look at why. We looked at what, now we look at why. And if we look at why here, we have to look at the reason for those things. Remember, it said it was basically a thrust deficiency and wing contamination. So why was there thrust deficiency? Well, engine de-icing wasn't used during takeoff. It was not required to be used based on the criteria for wet snow in the aircraft's operations manual. Wait a minute. This was never mentioned in the original report, that the pilots were actually following the instructions in the aircraft's operations manual. Now we've got another thing that people said something else. We've got another thing to look at. What about the operations manual? What about the procedures? Second, the engine inlet probes became clogged with ice, resulting in false high thrust readings. One crew member became aware of anomalies in cockpit indications, but did not associate these with engine inlet probe icing. All right. We are looking at a mistake or something that a behavior of the pilot that was not optimal here, but we didn't say he failed. He said he did. We make more of a factual statement. It didn't, because crew member failed to associate the cockpit indications with engine inlet. We said he became aware of the anomalies, but didn't associate these. Now we can do something about this. We can besides fire the pilot if they're still around. Now we can say, why didn't they associate it with it? And how can we change training? How can we change the cockpit design? How can we change whatever to make it easier for them to make that association? And number 4, despite previous incidents involving false thrust readings during winter operations, the regulator and the industry had not effectively addressed the consequences of locked engine inlet probes. All right, more information that didn't come in when we were focused on what the pilot did wrong. And we could do the same thing for the reasons for the wing contamination. You can look at those later if you want. But the conclusions, and I have another poll. Did you get a different view of the cause of this accident? I think there's poll number 3. I think I missed poll number 2, John.
No worries, I've got it. It's open.
Great. It's good that you understand me better than
Well,
more on top of this than I am.
This
This
question
shouldn't take very long. So
yeah, this one must be an easier question. People are immediately responding this time.
yeah, well, yes and no are pretty easy. and yes, you know, you do. You get a really different view if you write the accident report differently. Isn't that interesting? That it makes such an impact on how you write it. But the first one I showed you, the who, is usually the emphasis in most accident reports that I've seen. Maybe some people and some groups do a much better job, and I haven't seen many of them, but most of them do that. So Now, do you think it was just flight crew failures? Are there other factors? You already thought there were other factors, so we're not going to ask your poll on that, but it becomes pretty clear that there are other factors and that you don't have to guess at them. They're actually there. So there's two approaches. There's this accusatory approach in accident investigation analysis. You look at who and you look at why. The explanatory approach, which tries to avoid blame, looks, instead of who, it looks at what and why. We need why, but who and why focuses on why that guilty person we've already decided is guilty did what they did. The explanatory says, forget, don't make conclusions about it. Just look at the facts, what happened, and why they happened. And do you think the recommendations are going to be different? Well, of course they're going to be different. That was a rhetorical question. So another thing that happens is we use inappropriate, and we get to these, start doing these things because of inappropriate accident models. I'm not going to go into detail about this. We did this on Monday. I talked about this linear chain of event models where event 1 leads to event 2, which leads to event 3, and we have this whole linear chain. And Heinrich in 1932 did this for workplace safety and called it the domino model. But he focused on, he was really pretty clear about it was human error, because the first domino was always human error in his model. The Swiss cheese model, everybody likes it. It's the exact equivalent of the domino model. Look at this. Unsafe acts. An unsafe act is a person doing something wrong. And then there was all these preconditions of why the person made the unsafe act. You know, the wings could fall off this plane. The motors, engines could just all fail at the same time and stop. And it isn't in this model. There's nothing in this model about engineering design. There's you know, if you want to blame it on humans, it's great. And people love this model. I don't know why. So looking at the events is not enough. And I made this point on Monday. We need to look at why the events occurred. So here's a chemical plant explosion problem. The event is, and we're going to look at even some of the technical events have important why reasons. An automatic protection system was triggered that was designed to prevent liquid from entering the exhaust gas system, the flare. All right, you heard about that on Monday, and you know how flares work. But preventing the liquids from entering the flare also prevented the gases in the system from being discharged. So you don't want liquids in the flare, you only want gases. But by preventing the liquids, they prevented the gases, increasing the pressure in the reactor. Now that may sound like, fine, we got it, that's why. It isn't enough why. And so one of the things that CAS does, and one of the things I encourage people to do, is the right question. To use a technique and CAS especially emphasizes why, what questions are raised by this. So there's just no easy way to do this that's time efficient. So I'm going to show you what some of the questions might. Did the operators notice this? Was it detectable at all? Why didn't they respond when they saw that liquids were not, that the gases weren't going into the flare tower? This seems like a predictable design flaw. Was the unsafe interaction between the two requirements? There's two requirements here. One is preventing liquid from entering the flare, and the need to discharge the gases to the flare. Whether they identified in the design or the hazard analysis effort? If so, why weren't they handled in the design or in the operational procedures if it couldn't be done in the design? If it was identified, it wasn't identified, why not? Is there something inadequate or not powerful enough about the hazard analysis methods we're using that we couldn't find this. Those are all things I think we should be looking at in the accident investigation. Here's another example, same accident. Continued warming up of the reactors caused more chemical reactions to occur between the ethylbenzene and the catalyst pellets, causing that. This is, I told you, this was the one where they didn't think they had zero chance of the chemical reactions yesterday, that I talked about Monday. But anyway, the continued warming up of the reactors caused more chemical reactions to occur between the ethylbenzene and the catalyst pellets, causing more gas formation and increasing pressure in the reactor. Now, this seems like just a statement of fact, and that's it. You know, this is just a statement of what happened. But there are questions. For example, it says there was increasing pressure. Why wasn't the increasing pressure detected and handled? We have all kinds of pressurization, all kinds of devices to detect high pressure. Why didn't it detect it? Why if it was detected, why didn't the operators handle it? If there were alerts, why didn't they result in effective action to handle the increasing pressure? If there were automatic control over pressurization device like relief valves, common, I mean, a standard design pressure, why design technique about overpressurization, why weren't they effective? If there weren't automatic devices, then why not? Maybe it was infeasible to provide them. I'm not saying that this is the cause that there should have been, but these are the kinds of questions that should be generated from the events and that we need to look at, not just stop with, this is what happened. And you saw this before, accident. So STAMP is our accident model. This one says we have a hierarchical safety control structure. And it provides hazardous instructions to the process. There's inadequate enforcement of safety constraints on the process behavior. It gets feedback, but this whole process, feedback controller, doesn't enforce the safety constraints, which leads to a system state, a hazardous system state. Now, I said I promised I would do something in workplace safety. And so I will, because we had a surprising number of workplace safety people signed up, registered. So, these are also pretty easy to understand. So I do, but it was, you're gonna see, I can only go so far because this was a real accident. I changed it slightly to, because I'm not sure, because I don't want to give away the company that this happened to, but virtually I've seen this, hundreds of these, every single workplace safety accident report is the same. And not the same symptoms, but the same problems that you'll see. This was a scaffolding accident. They were assembling a very large, complex product in this assembly building. There was an important part that wasn't available when they needed it. So they decided to add it later to keep going, because otherwise they'd hold up the production line too long. And they said, well, just, go with what we have and we'll add it later. When the part did arrive, the problem is they had to assemble a large piece of the product to insert the missing part because it wasn't easy to get it in. So, and to do that, and this is a very large product, so there was scaffolding constructed, and the scaffolding had been constructed during the previous shift, all right? With this shift, the next shift went to remove that large piece they had to get off before they could put in the new one. The scaffolding kept it from being removed. It was like a large door, and the scaffolding was in the way, so they couldn't move it enough to remove it. So what did the workers do? Well, they removed floorboards out of the scaffolding so they could open the door. So they then removed the door, removed this big piece, and 4 workers were holding the piece, big parts. It's big, and they're all up on the scaffolding. and then they had to turn to move it down to the end of the scaffolding to take it down to the shop floor. But when they turned, remember it's a large piece, one of them fell through the hole in the scaffolding. It's sort of, the accident report is actually kind of humorous. The man was injured, but not he did survive. So I can say it was humorous, you know, that this accident report said, well, we were turning the door and all of a sudden Joe just disappeared. Here's the accident analysis. Here's the accident report. And this is what they wrote. They identified the root cause. And there were 3 root causes. The lack of experience in doing the job. So that's the worker's fault. They didn't know there was a shop aid for this job, so they didn't use it. And they didn't perceive any undue risk and didn't ask for help. It's all their fault. They should have asked for help. Hindsight bias. They didn't think it was a big deal at the time, otherwise they would have asked for help, clearly. All right, so what were the recommendations? Well, tell the workers not to remove floorboards from scaffolding. Oh, come on. Add tool information to the job instructions. And this is the kicker, the one I love both. During the daily kickoff meeting, discuss the potential hazards and ensure that safe work practices for the assigned tasks of the day. This is such hindsight bias. Sure, in the morning, they would have, during the kickoff meeting, the morning 10 minutes or whatever they have for a kickoff meeting, they're going to have, they would have thought of saying, oh yeah, and don't remove scaffolding, floorboards from scaffolding. If they'd gotten to that much detail, they would have been there all day going through every single possible thing that the workers would have done. This is clearly hindsight bias. Nobody would have done that. They used a causal analysis tool. Some of the worst causal analysis tools I've seen are in workplace safety. They're just silly. And this is sort of like a fault tree, but he called it it's called a reality chart. As if instead of using something generic, it's reality. So this is a sort of an example of what's called proof by naming. Is this right? It's reality. I called it a reality chart. Clearly, it's reality. So what did the reality chart show? Because I found this. It was in with the report, they included this reality chart. They said the error was the worker stepped in a hole. Well, yeah. And then it said, why? Lack of situational awareness. That's a fancy word, but it just said he didn't know the hole was there. Well, of course he didn't know the hole was there. Nobody steps in a hole on purpose if they know it's there. And the other one, there were 2 branches on in this silly thing. Made a mistake. Yeah, that's why he did it. He made a mistake. Well, of course, that's by definition. All of this note is focused on the victim and the workers themselves. Now, I looked at this and I just started, all these questions started coming up in my mind. Unfortunately, I couldn't do a cast analysis because there was no other information and I couldn't make it up after the fact. But why didn't the report ask? Why were they doing a job for which they had no experience and without oversight from someone who did have experience? Why was there nobody providing oversight on this? Why did they not know about the proper job aids? Whose responsibility was it to ensure that the right equipment was available and used for these dangerous jobs up on scaffolding? It's going to be dangerous. You can fall off by definition. Why didn't they ask for advice when the scaffolding prevented them from doing their job? This I actually have sort of an answer for. This company has this, and NASA does the same thing, you know. this equivalent of what they find a way culture. And they encourage everyone. This is the culture. Don't complain. Don't say you can't do it. Find a way to do it. Don't give up. And so I suggest that I was talking about this my findings about this workplace safety thing to some executives, and I said, I mentioned this find a way culture, and I said, what? Maybe you should change your culture to find a safe way. And they all laughed. They thought I was telling a joke. So I decided this was not going to help. I just gave up because they were not going to understand. Who provides oversight for this out of sequence work? We talked to some managers. Some other people and I were looking at this after the fact, this accident. And the manager, we said, well, and this is high up, not high up, but sort of medium, a couple levels above. And we said, well, what keeps you awake in terms of workplace safety in this company? And he said, well, I worry all the time about this out of sequence work. It happens all the time. I have no way of evaluating the hazards. I don't know what to do about them. I have to make all these decisions without any tools, formal tools, analysis tools, or anything. And this is my biggest biggest fear. Well, if that's your biggest fear, why isn't there someone providing oversight? They knew, if you know that that's really dangerous, why were these people just doing this work without anybody overseeing what they were doing? Why was blame for not understanding the risks involved placed on them and not their supervisors? So, the reaction report says, well, it's their fault for knowing what the risks are, not knowing what. Wait a minute. It's not the worker's fault to do a role to do hazard analysis. That's not what they're trained in. I see more companies, and I talked to somebody in this company, and companies say, well, the workers know more about the job than anybody else, so it's their job to do their hazard analysis and figure out what the hazards of their job are. No, that's not their job. We need people who are trained to do this. Why was incorrect scaffolding for the job constructed in the first place? It was done in the shift before. Why? Who was supervising it? Why did they do it incorrectly to begin with? Why were people constructing it not aware of what kinds of scaffolding was required? Who evaluates the hazards of out-of-sequence jobs? Was there documentation of the tools needed for the job? Why was the job not done when it originally was supposed to be done? Why was there no oversight of this out-of-sequence? I think I said that before, sorry. There was supposed to be, it turned out, a meeting about how to accomplish this work with the company. They were going to come and meet with the workers and meet with the managers to talk about how this was the company that's making this part that was late. But it says in the accident report that the meeting was never held. But it doesn't say why wasn't it held, and why didn't they just make the work wait until it could be held? Our workers often expected the jury-rigged solutions with no oversight or input from others, and I think that happens a lot in workplace. They're expected to jury rig, and because people say, find a way. This is said, figure out a way to jury rig, but there's no oversight or input from others. This is the same thing happened in Deepwater Horizon. This happens all the time, these kinds of things. Okay, so STAMP, accidents, and just a review, are a dynamic control problem rather than a failure problem. Hazards result from lack of enforcement of safety constraints in system design and operations. Losses involve the interactions of human, physical components, software, organizational factors, regulatory factors, culture, so on. Controls are created to prevent hazards. Accidents occur when the controls are ineffective. Accidents don't occur just occur when something fails, particularly some human somehow fails. I hate that word. In my classes that I teach in system safety, I forbid my students from using the word fail for anything but hardware. Hardware fails. Software doesn't fail. Humans don't fail. When I hear about a human failing, I think about their heart stopping and they fail, you know, they keel over dead. Companies don't fail. Well, they go bankrupt. But if they're not going bankrupt, it wasn't a company, you know. In the Shell Moerdijk explosion that I talked about a couple times, in the big news and headlines and in the accident report and everything, Shell failed to learn from experience. Remember, I said it had happened twice before. Shell failed to learn from experience. Well, Shell didn't fail. Shell's still around. It did not go bankrupt. Shell has something like 150,000 employees. So saying that Shell failed provides no help. Then it says you should learn. The only solution is Shell should learn from experience. Who in Shell? What? That doesn't help. I don't know how to do something about that. What I can do is go in and look and say, well, it happened twice before in Shell. Shouldn't that have been in the safety information system somewhere? If it wasn't, then maybe that's the problem, is we're not documenting events so that people can learn from them. If it was documented, why didn't the people see it that were designing the new plant? Is it hard to find? Is it not part of the procedures they use in designing new plants, looking at past experience? I don't know. I have no idea what the answer is because nobody ever looked at this in the accident report, but they should have. And if we'd learned something like we'd learned, well, you know, it's very hard to find. Well, now I have a solution. Now I have something I can actually work on and do something about. Okay, so control. So accidents occur not when humans fail or when something fails, but when the controls are ineffective. So what does that imply? It implies that what we need to do is, in an accident investigation, is focus on why the controls were ineffective. Aha, that gives us something different to do. That's CAS. CAS it stands for causal analysis using systems theory or systems thinking. And here are the goals I had when I created it. Minimize hindsight bias, one of my highest goals. When I read accident reports, and long accident reports, short accident reports, I find hindsight bias on every single page, often multiple times on every page. We have to get rid of it. Sometimes I can just search for should have, or the word should, and you know, it just pops up. This shouldn't be so easy to find, and it shouldn't be so prevalent. All right, so we want to minimize that. I want to provide a framework or a process to assist in understanding the entire accident process and identifying the systemic factors. So there is a process with steps. It's not a mathematical equation. There's no way to do that in these kinds of socio-technical systems, but it is a step-by-step process to help get at the right answer. I want to get away from blame who and shift the focus to why and how to prevent it in the future. And again, we want to focus on why people behave the way they did, not what they did supposedly in hindsight turned out to be wrong. And we want to focus on weaknesses in the safety control structure that allowed the loss to occur. So then we have something we can do about fixing these things. So CAST is a structured technique to analyze accident causality from a system perspective. It also helps to generate the questions to be asked. So if you're doing it along with the investigation process, you get the questions that you should be asking in the process. When I get these things after the fact, and I generate all these questions, I don't have any way to answer them. I need them when we're investigating. It's a paradigm change from what's done by other accident tools today. The goal is not to start by looking at failures. The goal is to look at why didn't the design controls prevent the accident. We almost always design controls into a system. We know when we're building dangerous systems, people don't just design it willy-nilly and say, well, we'll see. We'll wait until the accident occurs and we'll investigate it. We always design controls in. Why weren't they effective? And what changes in the controls are needed to prevent future accidents? And it starts by identifying how each of the components in the control structure contributed to the loss. It's what, why, not who, why. I have a website there. We have all kinds of publications and lots of examples of cast analyses. So if you want to look at them in just about any field, they're there. This afternoon, we're going to the two people doing the example will be an aircraft example, an aviation example, but the next one I'm going to do is hospital. Is a total, again, one we haven't focused on much in this so far in this tutorial in this week. So again, it's a change in focus from examine failures to determine why the controls were ineffective. And so I said I was going to do a hospital one, patient safety one. Hopefully, we had a lot of people from especially the UK National Health Service signed up. So hopefully people are listening. Haven't given up when they heard all those technical details about planes and booms and stuff previously in the week. So in patient safety in hospitals, they do something called root cause analysis. Just about everyone does this root cause analysis. It's a simple thing. You do the events that occurred. You find the first one, which is almost always a nurse or a technician. If you can find it, to blame it on them. If you can't blame it on them, you go up to a doctor. Rarely is anything ever goes above the doctor. And if you're stuck with the doctor gets sort of the blame, well, then he goes to his M&M meeting. It's a meeting they have when things adverse events happen, and says, I'm guilty, I'm sorry, it won't happen again. I've actually been working in patient safety for a long time and have had zero impact. I've probably been doing it at least 30, 35 years. And I found it almost impossible to change this field. So the students now, if they want to do it, have to really convince me to make me want to do it. Now, this one I'm going to talk about, and I'm going to talk about a real adverse event, a real analysis we did, was by Aubrey Samos, who is a doctor. She's an MD, but she's actually at Mass General right now. But the accident and the adverse events she looked at 30 of them, were in a large Chicago medical center. I guess I could say it doesn't really matter, Rush Medical Center, because one of the co-authors is from Rush, so it's obvious what it is. Also, I did say Megan O'Neill was listening and are part of the audience in the previously this week. She did the same kind of, looked at root cause analysis and the inadequacies compared to CAST at a VA medical center. And Lawrence Wong, who you'll hear today, he's actually in the Aeroastro department, but he got very involved and interested in patient safety and is now doing his dissertation in that. And he is working with Todd Palicki, who is who works at University of California, San Diego Medical Center. And he's looking at CAST, and he's looking at his dissertation as how do we translate this thing into something that can be done quickly in hospitals, because they don't have a lot of time, and can be done by people who don't have engineering training, and so he's doing actually a study, and he's trying some training techniques on them, seeing whether they're effective. So let's look at this one. What happened? This was, as I say, in Chicago, very large medical center. He was admitted to the hospital for a cardiac heart transplant. Written orders called for the administration of immunosuppressant medication before surgery as a prophylactic way, and make sure he doesn't reject the heart immediately. CCU, oh, I'm sorry, the cardiac care unit, that's like the ICU. We've been hearing way too much about ICUs lately, all of us. But this is the ICU for cardiac, reserved for cardiac patients. The nurse handed off the patient to the surgical team. I'll talk a little bit about handoffs, but it's a formal technique where the surgical teams comes to the CCU to get the patient for surgery, and they go through this asking questions and sharing information and so on. And the surgical team then takes the patient off to surgery. The surgeon started the surgery without the patient being given this immunosuppressant medication. The surgery was successful, but the patient's ventricular function worsened and was placed on ECMO. That's external respiratory and heart support. Again, we've been reading too much about that because a lot of the COVID-19 people are being the most serious, are being placed on those. And he was treated for a transplant rejection, but the patient did not survive. Okay, standard blame approach. And this is what the report said. The CCU nurse didn't give the immunosuppressive medication, didn't tell the surgeon that had not been given, and the surgeon started surgery without the patient receiving immunosuppression medication, despite executing a checklist before surgery. I'll mention about this. But basically, it's the nurses and the surgeon's fault. Okay, that's what the root cause analysis would say. Let's look at what CAST would say. So CAST has 5 steps instead of the 4 steps STPA says, but it starts out the same way. Assemble the basic information, model the safety control structure. Now what we do is analyze each component in the safety control structure in the loss. If you don't have them all in the safety control structure, you'll add them as you go along. You'll find the ones that you need to add. Identify the flaws in the entire safety control structure. We started by looking at each individual component. What about all things that are systemic or are endemic or whole, for the whole safety control structure, and then create an improvement program. So let's go through those steps for this thing. This is actually much easier now because we know the hazards and the accident, they call them adverse events. So I just use the technical term used in patient safety, adverse event, instead of accident. And but this is much easier because after the fact, we know what these are. This is hindsight bias. It's okay because there's no point in doing a whole STPA and finding all the different things that could happen, hundreds of things, when we know what happened. So we can focus on what happened here. STPA is appropriate for before the accident. CAST is much better and more efficient after. So the adverse event is the patient experienced rejection of the transplant and died. The hazard is patient not getting proper pre-surgical medication. So our goal now is to determine why the controls in place weren't effective and how to improve them in the future. So second step, that's just the basic information is really usually easy here. The second step, model the safety control structure. So this is it. I'm sorry, it's a little slow. It's a little small, but I couldn't get it bigger. At the very bottom here, we have the patient. Above the patient, we have the CCU, the cardiac care unit nurse, RN, whose responsibility is to administer the pre-operation medications. The process model, the important part of the process model, again, we don't have to look at all of it. We only have to look at the part that's affected here. Were the ordered meds given? Yes, no. And is it my responsibility, we'll see, to give it. The circulating nurse is just another, the surgical nurse. The circulating nurse is in the operating room, and her response or his responsibility is to do a final check of whether the patient's ready for surgery. Above them is a surgical fellow, the first assistant to the attending surgeon, and his responsibility is to order preoperative antibiotics and immunosuppressant and ensure that they've been given. Clearly, didn't happen. And the process model where they were the appropriate meds ordered, were the ordered meds given. We have a surgeon above here who also is responsible for ordering antibiotics and immunosuppressant. When you sort of see this, multiple people responsible for the same thing, a red flag should wave. Ensure the patient's ready for surgery before beginning, and execute this timeout, which I'll explain in a second. There's also a nursing supervisor that oversees the nurses and in the critical care unit, ensures that the medication procedures and the handoff are being executed appropriately, and identify the necessary improvements in the procedures. I'm going to give you a hint before. This had happened before, all right, multiple times that the meds weren't given. So this wasn't a one-off. This wasn't a one-time event. And then there's the ICU management, who establish the medication procedures, oversee the implementation of the procedures, investigate the adverse events. And above the OR, there's OR management. But one of the things we're going to see here is that there's two parallel control hierarchies, neither of which interact with each other or have any way of interacting. And that turns out to be a part of the thing that was never investigated or even thought about at the time. All right. Remember I said STAMP says we establish controls. Accidents prevented by the controls. So in CAST, we have to look at the controls that were provided. And so these are the controls that are in most places, and in here, they were in this process to ensure the proper medication is given. There's something called the written order sets. Order sets are just the set of things that have to happen before the patient gets surgery. And so those are put into the electronic health record, the EHR. There's also, so in there, it says that the patient should be given immunosuppressant. That was one of the things, plus other things, given antibiotics and other kinds of orders. There's a handoff of the patient to the surgical team, which I talked about how they're supposed to coordinate and ask questions. Unfortunately, it isn't well structured. So we'll see that the wrong questions were asked. There's this timeout I keep talking about. This is a checklist. All the pilots there are going to know exactly what this is. What happened is that hospitals have had a terrible time with patient safety, and they've tried all kinds of things. They sort of grab these little things. And one of the things they grabbed from aviation, they said, well, aviation has small number of accidents, and pilots are actually helping them with this. What does aviation do? Well, they do checklists, so we're going to do checklists, and that'll solve our problem. You know, picking one little thing out of a large system that all is works together is not going to work, and it hasn't worked in hospitals. although they haven't quite given up on these checklist approaches yet. But they aren't working as well as they thought they would. And the thing is, of course, you know, we know pilots don't always do checklists right either. And there's been a lot of work on how to design checklists, to make it more probable, likely that the pilots will be able to do them and will be able to do them effectively and well and on time. And there's system controls around in case they do. They're designed in the plane and others in case they do miss some of the checklist items. So it's not just a one thing, take that little piece out, put it over here, it's going to work. There are other operating room checks. There's that circulating nurse, that operating room nurse, as I said, is also checking. There's the surgical fellow, there's the attending physician, all of them have checks that they do. Turns out none of them were successful in this case. So what we have to do is not figure out who did what and who's guilty, but understand why those controls weren't effective. To do that, we need to look at both individual behavior, the operation of the structural controls in general, and the operation of the entire safety control structure, the SMS that I talked about yesterday. Turns out everyone involved had incorrect process models. So for example, they thought the meds had been given and the immunosuppressant had been given when it had. How do we update our process models? Well, a lot of them are by feedback loops. But it turns out in every accident I've done cast on, we always find lots of missing feedback paths. And so STPA, of course, we could use to try and we should use to try and make sure all those are included beforehand, but because they're a big problem if they're missing during operations. And we also found that the controls and the control structures as designed were not effective. But then that gave us all kinds of clues on how to make them more effective. Okay, so next step, analyze each component in the loss, the contribution to the accident, their mental model flaws, the context in which our process model, they're mostly humans, so mental models makes a little more sense. The context in which, you know, this is all related to STPA, but we're doing the same thing, but we're doing after the fact, and we don't have to do it, all of it. And the questions, generating questions that we should be answering later in the investigation. So let's look at these. Was the cardiac care unit nurse, the CCU nurse. The responsibilities, we said, administer preoperative medications, report any concerns about patients to the surgical team when they do the handoff. What was their role? By the way, I have trouble with this. I first started by saying the unsafe control action, and Sidney Decker chewed me out horribly. He said, that sounds pejorative, don't do that. So I said, well, I have to say what they did wrong. He said, well, use some other word. And I've tried and tried. This is the best I've come up with. What role did they play? Because they did play a role. I mean, she did play a role. She was involved in the events. So there was a role. She didn't give the preoperative immunosuppressant and didn't tell the surgical staff that the patient hadn't received the medication in the handoff. If we stop here, which is where we usually stop, nurse is guilty. I mean, clearly, she didn't do those things. But we can't stop there. So if we really want to find out why, we need to know why she didn't. Was this just some kind of, bad day for her or what? So we do two things. We look at the process model flaws and we look at the contextual factors that explain this. So first of all, what was wrong with their process model? Well, it turned out she wasn't aware that she needed to give the immunosuppression. She thought that they would be giving it in the operating room. How was she supposed to know? Why didn't she know that? And as it turns out, it's related to this order entry. Remember I talked about this electronic orders. They give this list of orders in the electronic health record, but there's no indication of who's responsible for what in the orders. It just says it has to be done. Now, most of the times it works. So, but because they've been doing the same thing and they do it every day, and so they pretty much know what their jobs are. But look, remember I said accidents occur after a change? It had been several years since they'd done transplants, heart transplants, so they weren't aware of the requirements for the operation. Checklists aren't going to help here because it wasn't clear who was supposed to be doing what. Who's responsible for training on the changes in data? Was there a management of change procedure that was defined and used? Because this was a new change in procedures. What did they do when they were changing procedures? Obviously not enough. She wasn't adequately trained for the CCU. Why not? Who's responsible for this? Why was she assigned to the CCU when she wasn't trained as a CCU nurse? We're gonna have to look, that's a good question. We're gonna have to look that up. Antibiotics were a part of the preoperative order set, but the floor nurses don't give them. They're given in the OR. Could that have created confusion about who was responsible for giving the immunosuppression? Remember, we have the order set. Some of them are antibiotics, some of the immunosuppression. Nowhere does it say who does what. As I said, I just said that, doesn't specify who's responsible for carrying out each order. The operating room nurse does the final check. Didn't stop the surgery from proceeding despite the patient not having received immunosuppressant. Why? Well, her mental model was wrong. She believed that the patient had received it. How was she supposed to know? Why did she think it had been given? Nobody mentioned a concern during the timeout. On the order screen of the EHR, there's no record of whether an order has been acknowledged or carried out. All of this is on the EHR. It's on this electronic screen. EHRs have been a disaster. The government decided everything had to be electronic, and they forced hospitals to do this, some with both carrot and stick, gave them money to do it, and then punished them if they didn't put in EHRs quickly. The AHR companies came up with these and didn't know what they were doing. They were good computer scientists, but knew nothing about medicine. And there have been horrible problems with the AHRs. The preoperative timeout checklist is a generic checklist, so it doesn't explicitly ask about preoperative immunosuppressant. So it wasn't on the checklist. There's a trade-off. You can put a large number of things on the checklist. I mean, there's a lot of things that would go in here of all surgeries, or versus fewer, but more likely to be executed. We know this with pilots. We know that the fewer things, you usually put the things on the checklist that, are the most critical, because if you have a very, very long checklist, people won't have the time to finish it. So they had a very few things on the checklist, but the problem was that there wasn't something, and there were things that were irrelevant on the checklist. For example, wrong site surgery. That's a very common thing. You take, you operate on someone's right knee when the problem was in the left knee. And that's important to have on the checklist. With the heart, there's no left and right heart. They're not going to take out the pancreas. So it's not an important thing for the checklist, but it's on it. What about the surgeons? Didn't ensure the medications be given, ordered it, so they believed the patient had received it. How is he supposed to know? Well, it's supposed to be on this EHR, but he couldn't find it on the EHR. There's no way that he knows. There's no feedback. Missing feedback. On this, oh, this is all about that feedback. You can come back. Patients come from the cardiac care unit where surgical teams knows and trusts the nurses. That's what they do. They do the same job every day. So they don't feel the need to check up on their work. The nurses specialize in cardiac patients. I don't know what that was. So they assume they should be able to be familiar with the preoperative medication. Sorry, it was getting late last night. The same thing with the attending surgeon. I'm not going to go into all of that. Nursing supervisor, there's somebody who, and one of the things she does is assign nursing staff to the CCU, but this was an inappropriate nurse for the CCU, didn't ensure the proper training and procedures were being executed, weren't aware that medication errors were occurring, and they were occurring, but they were never really investigated very well. Budget had been cut. She couldn't always find cardiac qualified CCU nurses. Had she complained about this? I don't know. And other things here that we were looking at afterwards, and it was a little late to find out why some of these things happened. We couldn't ask the people. The OR operating room administration didn't establish safe procedures, allowed inappropriate timeout procedures for the transplants, didn't identify the systemic factors in previous accidents because they're responsible for investigating these adverse events. Why? Well, obviously they thought the timeout was appropriate, the procedures are adequate, and the RCA was an appropriate way of investigating accidents. Otherwise, they wouldn't have done it. Look at the contextual factors. We found several medication errors were never investigated thoroughly, but had the same and very similar causes. But instead, they stopped with blaming the specific medical staff, said that person made a mistake, done, gone. So never found the problems with the AHR, with the timeouts, with the missing feedback, and so on. The trade-offs between cost and safety permeated their decisions, including staffing levels, personnel training, equipment inventory. There had been a complete turnover of the management team, and they had different specialties and different styles from the management team before the accident. They came from a hospital that specialized in cardiac transplants. They decided that they would rush to have it be a major part of their income was from heart transplants. But there was no plan as to how to do that from a group that almost never did them to one that specialized in. Again, a change, management of change. The CCU administration, well, you can read these. There was a separate management silo for surgery and intensive care that complicated the communication. I remember I said there were two separate control structures, and there were communication problems. The next step in CAST is to identify the overall control structure flaws. The things that aren't in the individual. We want to look at the individual components, but there are some things that are just wrong with the whole design of the structure that we need to look at. And here's some of the things here, and in my book, Engineering Safety, where I talk about various types of things that go under this category. In this case, the safety information system, I said that yesterday, safety information system is critical. In this case, it's the AHR, the electronic health record. It had a poor layout, didn't provide clear instructions from physicians or provide clear feedback about the carrying out of the orders. The order set, the way, I don't know what I said, forgetting to place it, but the design of the order set and stuff, and the use of an order set. Oh, I remember I said, order sets reduce confusion because they contain all the set of orders. And so by making the surgeon give individual orders to different people, it's more likely that they're going to forget some. But if you put it out in one order set and the surgeon looks at all the orders and things can see it's complete, on the other hand, it decreases the chance, it increases the chance of confusion because of who's going to actually fulfill the order. I almost got that out right. The time assigned to each order, but no mention of who's responsible. For common surgery, everyone knows their role. So it works. But the heart plans here was less common, had not been done for a long time. So there's confusion about who was to do what. One of the, when you start hearing this, think about it. Are you thinking about recommendations? The recommendations just sort of shoot out at you. Clearly, we need a management of change procedure when we make these kinds of changes. We need to change the EHR. We need the feedback. I mean, it's so clear what the changes are needed to fix these problems. Communication and coordination, the handoff, the timeout, all these things, I talked about them briefly. We're running out of time, so you can read them. There were communication difficulties between the departments. There are these autonomous silos between the divisions in the hospital, and missing feedback channels or communication channels between these needs to be fixed. That's something we can do that won't just prevent a problem with immunosuppression in the future, but will provide, hopefully prevent hundreds of adverse events in the future. Safety culture. I don't want to go into the safety culture problems in hospitals, but one of them that I've run into personally is this bad apple theory. There is a widely belief in healthcare that there are certain bad apples. They cause all the accidents. So there's 5% of the surgeons and they're causing all the accidents or all the problems. If we get rid of those bad apples, the 5%, then all our problems will be solved. And this was actually more than in healthcare. It was very, very common 50 years ago in most industries, but people discovered that it wasn't always the same 5%. Yeah, you could say not everybody's making the mistakes, but it isn't always the same ones that are making the mistakes. We wrote a paper on this stuff I just showed you about the problems we found using CAST in hospitals, and the editor wouldn't even send it out for review. Instead, she sent us back a letter saying, this is just bad apples. If we just get rid of those bad apples, then the problems will all disappear. We don't need CAST and all this nonsense. We did get it published eventually, but we had to go to a different journal. Confusion about responsibilities. Accidents often arise in the interfaces between departments like this. Dynamics and changes over time was clear. All right, and then in the end, you have to create an improvement program. You generate recommendations. There are obvious ones here, how to implement them, feedback, and follow up to make sure they were effective. So the standard blame approach, the CCU nurse didn't give. It was the CCU nurse, the nurse again, and the surgeon is the problem. I'm going to, well, let me do it quickly. There are other things, systemic factors and ways of looking at this problems in this overall control structure. This was, in fact, this is the Überlingen accident. This was a collision of 2 aircraft over southern Germany in Europe. This is what we did was draw, this isn't a control structure, but this is a communication diagram. We just drew a diagram of all the communication links in this system. And because of they were doing maintenance and some other things on, these were the communication links that were actually effective in the accident. It's very helpful, and it's a really good, effective graphic way of seeing what the problems are. In another accident, this was a water contamination of water. Public was exposed to E. coli in the water system in Canada. Here's the system hazard. There's the constraints. Now, there's a government testing lab here, which tests reports from these local water systems. But the government decided to save money and to make privatize the government testing lab, and they only interacted with the individual operations, the private labs. There's nothing wrong with privatization except that they lost all their feedback. So they didn't make the private labs report to the Ministry of Environment, and it turned out these people have been doing operations, again, lots of incidents before, doing things wrong for a long time until finally something horrible happened. Okay, conclusion. The model that we use in accident incident analysis determines what we look for, how we go about looking for the facts, and what facts we see as relevant. A linear chain of events model promotes looking for something that broke. Something went wrong in the proximal sequence of events prior to the accident. Then we choose some kind of stopping point, usually arbitrary, where something physically broke or an operator error in hindsight occurred. But unless we look further, we limit our learning, almost guarantee future accidents related to the same factors. The goal should be instead to learn how to improve the safety controls, the safety control structure, and not to find someone or something to blame. Leave that to the courts. Leave that to the lawyers, not our problem. Our problem is to prevent accidents in the future. We need to use accident analysis processes that avoid root cause deduction and oversimplification, that minimize hindsight bias, that are explanatory rather than accusatory, and that emphasize a broad contextual view of human behavior. Why did the person think it was that they were doing the right thing at the time? And how do we change our system to help them see next time, or help everybody see that it isn't the right thing to do? CAST provides a structured process for learning more from accidents. It generates questions that need to be answered during the accident investigation. Now, we were going to have a discussion, and I've run out of time. So if there's some time this afternoon, with the example that you're going to do in aviation I told you about, or there's in 2 weeks, the last week, there's a whole session, an hour and a half on CAST. And we'll probably, it's not clear yet, but I may spend a little bit of time on these because there's a lot of complaints about this. Well, let me spend a minute because it really doesn't take that long. People sometimes complain the CAST finds too many causes. This blows my mind that this is a complaint. But that's because we're learning more from each accident. So we're going to have fewer accidents because we can fix more and we're learning more. I will have fewer accidents. It just makes no sense to say, I don't want too many causes. I want something simple, and it's usually a person I can just fire. Also, you can prioritize the recommendations. If there generates a lot of recommendations, we don't need to respond to them all immediately. You can respond to the ones that are most important first and respond to the others later. But to stop learning because you found too many causes of the accident, then stop investigating is just stupid. Liability. There's no, what do I do if I can't say who's responsible? Not our problem. Should be determined by the courts, not by accident reports. Liability injects politics in what should be an engineering process. So the accident reports are really biased. There are large companies, there are other people with a stake, do not want the accident reports to blame anyone but the pilots. And for example, in aviation, that's politics. If we're going to improve, we got to get politics out as much as we can of the investigation process. It takes too much time. Well, that's what Lawrence Wong is investigating for his PhD. First of all, the control structures are reused. We don't come up with a new control structure each time. The reports now take a long time to produce in industries that do a good job, like aviation. I mean, it can take a year, 2 years before we haven't gotten the Boeing 737 MAX report yet, the official report. They're usually very comprehensive anyway. CAST is not going to take longer. CAST generates a different set of questions to ask, a different set of conclusions and recommendations. Lawrence Wong, as I said, Lawrence is looking at how do we do this efficiently in the hospital. We know hospitals don't have time. They're not going to spend 2 years on an accident report. Can't. Just impossible, socially impossible. Can they do this as quick and get more as the root cause analysis is done as quickly and learn more? And that's what he's doing, and coming up with some set procedures and ways of doing this that are pretty interesting and fun. All right. CAST handbook available up on the web on our website again, and it has a free download. So sorry I went over, but I started a little late, so I'm really only 5 minutes old.
Hey Nancy, that was great. You've got a lot of engagement here. There are some comments requesting a bio break. What do you think? Okay. Maybe we should take a short break. What do you think?
Yeah. So, well, let me just drink some water. So let me take a quick 3-minute break. And then I'll have to go find the questions. I haven't had a chance to even look. I lost my chat window. I can't figure out how to get it back, so I can't even see that. But I can get Slido. So let's take a quick break and let people off until we start again, which is about 45 minutes. Because artificially, and then I'll be glad to answer questions if people want to stay around. Okay?
Great.
Okay. Let's see what we got. Oh, the email list. Sorry, I explained about the email list. Let me just answer that right now. Spammers use it. The problem is whenever I go to a conference, conference meetings don't put out email lists anymore. Because the spammers use it, they sell it. They're companies that sell the email lists, make a lot of money selling them to everybody and their brother, and then you're going to get hundreds of spam email lists that have nothing to do with what you need. And I get them, and it's horrible. So unfortunately, I'd love to provide an email list. We used to do that with this conference, but we stopped about 5-6 years ago because I found that spammers were selling the addresses, the email address.
This is Nancy. One of the things that has been going on behind the scenes is the medical community has become very engaged. And there's at one point where people were almost desperate to communicate with each other, that they were posting their email address saying, please, everyone email me. So what I did, there were so many of those email addresses. What I did, Nancy, is I just added a section on our website where you can opt in if you want to share your email address. You can post your email on a form. It's not publicly accessible.
Oh, good.
But I offered to go through the chat window.
There are those bots that go around collecting anything that looks like an email address. If you put I don't even put my own email address up on the website because they collect them. That's what they do. I always write @. So if we write AT instead of using the @ symbol.
Well, this won't be, you don't have to worry about that with this. This is not going to be posted on our website anyway.
Oh, okay.
It's a form. So you'll have to submit the form. The form only goes to us, And what we can do is just send an email with everyone's email address on the CC list if you choose to participate, and then you'll have each other's email address directly.
Oh, okay. I'll let you figure that. You're more technical than I am. I just know all the things that bad things have happened to me, like spam bots. Oh, somebody said right on with emails. After I attended an INCOSY IS symposium in 2017, my spam shot through the roof. Yeah, that's what happened, unfortunately. The internet was supposed to be wonderful, but it has some drawbacks too. So I need 2 minutes.
If you're looking for the survey that I mentioned, go to our website. Look at the slide that's being shared right now. I'll post a link in the chat window too.
And I'm just looking at my mail to see if there's something horrendously awful happened. I've looked at my mail for an hour, 2 hours. All right, nothing tragic. Lots of spam. More spam. Okay, so, oh, so I see your thing about the website. So let me go back. Slido. The recent Atlas Air, somebody wanted me to comment on it. Why don't you ask the pilots this afternoon, Lawrence and Shem particularly? I think Shem has been doing a cast analysis of Atlas. Shem, are you on? I know you're on here. Have you been doing Atlas? Well, ask him. I'll put it off on him anyway. That he can answer it, because I'm not as familiar with the Atlas Air as I should be.
Hello, can you hear me?
Oh yeah, Shem, we can hear you.
Okay.
Haven't you been looking at Atlas? I thought you had.
Yeah, I did actually do an atlas. I did a really quick one. Hang on, I'm just trying to fix my settings here because.
Okay, so they say, so the question says, it looks primarily to an operator error issue. Were there systemic issues missed?
Yes. That would be an understatement. Yes. I'm trying to
They're
figure out
always
my video
It's
here.
always a safe answer.
Yeah, there's quite a few. You know, it doesn't get into you know, why the controls didn't work. You know, in this case, the pilots are one of the controls, but you know, why did that control not work? You know, of course, it's one of the questions. And just trying to mess with my video settings so I can make this work at the same time I'm talking to you. But that definitely was, sorry, I'm just trying There's gotta
Somebody
be
else, it may have been
database.
you, wrote, I did a quick cast on the Atlas Air accident a month ago. There was definitely more
Yeah,
involved operator error. Was it you?
yeah, that was, for some reason
Oh,
it
okay.
didn't. I tried to, all right, why is it acting like my camera is hooked up? Maybe that's why things aren't working. Oh, yeah. I guess that would make a huge difference, I bet. Hooking up my camera. I had a complete meltdown.
Well, somebody here, while you're doing that, somebody is taking me to task for not liking the Swiss cheese model. I didn't go through all the, I can go through, I have a paper right now that I'm writing about, I can go through all the problems with the Swiss cheese model. It is a linear chain of events. It misses most everything. It misses the real systemic factors. It has some things that are control and failure devices, for example, to prevent failure. Everything's a failure again. Latent failure doesn't make any sense, by the way, technically. It says they love it. I hate it. I think that it misses all the important stuff, and it has all the problems. It is just a chain of events, and it's only some events that it includes. It doesn't even change all the events, and so we'll have to disagree on that. But I think that using that makes you, HFAX is built on it. And HFAX is notorious. We compared CAST with HFAX, and HFAX finds only operators and but that doesn't include managers, but they're all guilty. Instead of looking at the systemic design issues. And that's what HFAX, and that's what reason makes you do. Those are not the systemic factors, those things in the Swiss cheese thing. They're just controls, like a flare tower, like they're the defense in depth, comes right out, it follows the process industry's emphasis on defense in depth. And if one fails, then the next one is going to somehow hold. That's a whole assumption between the chain of events and the reason model. It isn't true. What about things that there's production pressures, or there's financial pressures that take out all the Swiss cheese slices? There's no protection anymore. They're all gone in one fell swoop. Sorry. Now you can go back to Atlas Air if you want, Shem, if you're ready. Oh, so are you still looking?
I'm trying to make it work.
It's is or should CAST be a part of STPA? No, they're different tools. CAST is an accident analysis tool. It's after the fact. STPA is a proactive hazard analysis technique that occurs before the accident. So they're different tools. They're doing for different things. CAST isn't part of STPA, but they're similar because they're both based on STAMP. That's where the similarity comes. They're all based on the same theoretical foundation of how accidents are caused. Okay, so Shem, are you ready? Oh, somebody answered that. Somebody said exactly that. CAST is separate from STPA and both based on STAMP. Thank you. Oh, they're all answering that. Good.
All right. I think I'm getting closer here. Now there's
Oh, somebody wanted to change the term human error. Yeah, I don't like the term human error. If you can come up with a better term, it's better. But it's certainly better than human failure, because that's just pejorative. That's blame. That says is the end. Human failed. That's it. Someone asked if this is related to Boyd's OODA. Look, everything, all of these things are related to control theory. It's just based on control theory. So anything, most modern engineering is based on control theory. And the techniques, these things like Reason's not an engineer, and he's a psychologist. So a lot of this stuff is done by non-engineers, but engineers understand feedback control loops and lots of stuff done by engineers. That's the only relationship I think with Boyd OODA loop. Is there a publication of this? Yes, there is. There's a master's thesis, but there's also a journal paper. We did get it published in the Journal of Patient Safety. So write me and I'll send you it.
So I am trying to just double check it. There's a way to put a white screen up on this, right?
There's what?
Is there a way to put a white, like a, just a,
Yes.
I don't
Yes,
know.
Jim.
John,
You have
John's
to
the
click
tech.
share screen or new share,
okay.
and then go to the right if you're looking for whiteboard. Do you want to draw something?
Other screen share. Well, I will when I'm doing this. I'm planning on
Yeah.
on using a whiteboard and actually drawing this control structure in
Yep.
real time. That's basically my thought.
So click share screen or new share, and it'll pop
All right.
up with your
So
different
it's going to
screens.
stop the other
Yep,
one.
That's fine.
And I did create a Slido that's cast 23 that for an event code that, so I went ahead and got an account so we can,
All right.
oh, I see it.
We've got a half hour though before you start. Is that right?
Yeah.
Okay, so there's some questions here while you're setting that up. They're quick. Shouldn't liability in politics be part of STPA, for example, regulatory capture? Those aren't liability in politics. That's control. There are various control parts of the government. We should treat this as a socio-technical system. And yes, it is an STPA. You haven't seen the examples. When I do STP, I include a lot more in management and socio parts of the problem and make my students do it. But engineers sometimes like to focus on technical parts and get all involved in them. But yes, they are. They definitely are in STPA. Is damp and cast a foolproof concept for designing a control system? Oh, no, nothing's foolproof. I don't know of any perfect techniques. I certainly will never claim that I've created something that's perfect and foolproof. And we need to improve these tools, by the way, to make them easier for people and better for them to use. But, you know, there's no perfect thing. We still have plane crashes for things, you know, unknown aerodynamics principles and stuff or mistakes we made. There's no perfect. Sorry. But better. That's all we get. All I guarantee is better because I can show that. I can compare them. Until what time can we submit the homework today? I assume that John's answer will be you can do it anytime you want. He's just not going to be able to process it. Right?
That's right. I've got to wake up in the morning and I've got a couple hours to go through all the submissions. So earlier the better so I can get a head start today. It's not a long assignment. It's just give a quick sketch of a control structure in some event that you're familiar with.
He's going to go over the answer. And if you just have your answer sitting in front of you and it hasn't been submitted to him, it doesn't matter. But if you submit it to him, he can make comments on it and can also use it, the information from it for his presentation of the answers. Okay, Shem, you ready?
I think I've got it working. I've just been playing with it because it's drawing slightly different than I expected, but that's all right. It's good practice anyway. So we're starting, we start at 12:30 though, is that right? Do I have the calendar correct?
That's right, Jim. Eastern
All right.
time.
So I created an initial, a Slido for, I just did cast 23, which is, in fact, I'll put it in the chat if I can find what happened to my chat window. I've got so many.
I'll put it there for you, Jim.
Yeah, it's cast 23. What? I don't know what
I
happened.
love this. I thought the checklist manifesto solved the hospital patient and issues. Unfortunately, no. You're not going to fix the hospital problems because they're systemic. They're not just at the checklist level and the individual human behavior level. I didn't tell you the master's thesis that example came from. We actually found we examined 30 adverse events that occurred despite the fact at that hospital in cardiac surgery, despite the use of the checklist and the timeout. And so the thesis really talks about all of them, and none of them could have been solved by a timeout. There's no magic bullet, folks. No silver bullet.
So the cast on the Atlas actually was very interesting. And we did come up, there were several other items. I don't think you've had a chance to review it yet, Nancy, because you were swamped with this thing.
No, I haven't even had looked at it all.
So it's interesting though. There definitely was a lot more to it than has come out so far.
Oh, here's an interesting question. You think it's easier to do STP or CAST analysis? I think CAST is easier.
Definitely.
I can teach CAST. You can now, seeing what you've seen, looking at my handbook, there's no extra teaching necessary. You can go do CAST. Maybe you can ask a few questions somewhere, but you can do it. That's not true for STPA. What you saw on STPA isn't enough to really make you an expert on use it effectively. You need more training.
Right. It's definitely, I think STPA requires more imagination. And you also have to go through the 4 ways that controls might not work. I mean, that takes some time. You already know, obviously, with the,
You know what happens. You just have to sort of understand why. The other, you have to come up with all the ways, things that could happen first.
Right. And then dream up scenarios, whereas in CAST, you already have your scenario. And I think those two things, to me, make the biggest difference. I don't know what other people, how other people are seeing that, but I figured out how to make it's good to be doing this where I have 2 screens. A lot easier than on my laptop. All right. And Lawrence, you're there somewhere?
I am present. I hope you can hear me.
I can hear you.
Awesome.
So it's I hopefully don't get interrupted by a thunderstorm that seems to be trying to pass over here. So there's a bit of a risk. So I think we're going to have 2 scenarios. We're just going to run through it, and I'm going to use the polling and basically have people answer the questions as we build this. I think that would make the most sense. And we'll just come up with something similar. We'll see how much time we have, though, because we don't have that much time. Obviously, we're not going to be writing a whole paper and getting into the one of these long ones. So we're getting a lot of different industries, aviation.
A lot of comments about checklists and other things. They're all really good. Someone says depressing. Haven't had any impact on patient safety. Actually, I agree. I gave up years ago, and if Lawrence hadn't come, I wouldn't be doing it now. But Lawrence said he wanted to do it. Decided to stick my toe on as he was doing.
John, is there a way for me to share the this Slido with the other panelists? Like my view of it?
No. I can't either on my account unless we pay to upgrade. If you pay them enough, you can.
A lot of comments about EHR. I actually did get involved in EHR a few years ago. I gave some talks at conferences. I tried to be diplomatic, as diplomatic as I can be, and I talked about the problems, and it was too political. Government wanted it, and there wasn't much that can be done, and nobody was going to make the companies fix them. I got involved with some medical doctors on a group that actually was looking at the safety of EHR, and we did some interesting work. But safety of EHR is politically deadly topic right now, and the EHR really is a problem. Doctors are complaining about them. Some hospitals are actually throwing them out. Doctors are refusing to use them. Sometimes doctors have said that all the electronics and the change in medicine has made them leave medical practice. We got to do something about that. Oh, someone found my paper in the Pay Journal. It says patient safety. Boy, you guys are good. There's a link to it in the chat window. It's in that paper. Any chance of a short break? This is good break time for all of you. How can I get the recordings of the sessions? We explained that. Let's do it again because new people are turning in. MIT is under a court order now. They were sued and has agreed to not put any public recordings of anything that MIT faculty and stuff are involved in, or MIT, without captioning. So we need to get it captioned. They will be published, they will be put up. We're going to try and do some of the tutorials first. We hope to have it maybe by next week. Akamai has agreed to fund the captioning by professional captioners. They will be up in a few weeks. Everything that anyone agreed, all the speakers have to agree. Of course, all the MIT people and stuff have all agreed. But some people in a few companies, their companies management won't let them put them up. But most everything's going to be taped and will be available. We'll send out information about that to everybody registered.
Hey, John, how do you switch the Slido to display in like you did?
I
what
guess
they.
this wasn't a
At,
good idea, Shem, right? Having you guys
at
do
the
this.
No, it's good.
at
We just have
the
to wait. We're just waiting until the time. So I'm just getting things set up. It doesn't matter, but it doesn't hurt.
at the top, Shem, there's a green button that says Present Mode, and you can click that or click Present in a new tab.
Okay.
Is that what you were looking for?
No, I was just with you had it display at a as a
Okay, this
instead of a list
politics.
form.
So while you guys are doing this, let me talk a little bit about politics and EHR and my experience with this. I've had some really bad experiences, I have to tell you, with medical community, and it's not the medical community's fault. Most healthcare providers really care. Um, there was a nurse in the Netherlands who used SDPA on their EHR system, uh, uh, pharma order entry, um, electronic order entry thing, and he used SDPA, and he found all kinds of potential problems. And the company that made the EHR uh, contacted the hospital and said, if you publish this or let this out at all in any way, we will sue you. And if
Hey, John.
your contract, you're not allowed to do this. So he couldn't share his SDPA results. I saw them, but this is where the politics and the lawyers, I said, blame is the enemy of safety. Um, Lawyers get involved and we have big problems. So yes, we actually, STP has been done on EHRs, but nobody will let anyone publish this stuff. That's the people that build the EHRs. And they seem to have a legal way of preventing it. Oh, someone said, I thought NTSB accident reports are not admissible in court. I don't know. Maybe that's true, but they still, and it's not NTSB. NTSB does a really good job. So let's not push on the NTSB. Just accidents in general tend to focus on blame. But there are all kinds of politics, even in NTSB reports. The companies are involved. There has to be unanimous agreement about what goes into it and some parts of it. It's problematic. Task handbook link got a 404 error link? Huh. I'll figure that out. Sorry. My server has been flaky because MIT doesn't have many people around. They're all locked out of the buildings. And whenever the computers go down, there's nobody around to put them back up. That's probably what happened again. I'll figure that out, but I won't be able to do that till the night. Then I have to get someone to start my server again. Is there a way to show the Swiss cheese model with bypasses or things it misses, just telling folks that maybe it's ugly will not get their attention the right way? Yeah, I mean, I have papers on this. I just don't have time to didn't have time this week to go into all this. My Safety 2 paper actually goes into a fair depth. People have asked about it. It'll be available next week. People have asked for it. Foolproof now. Shim, it doesn't look like you're going to get this going. Nancy, what's your opinions on Rasmussen's thought? Rasmussen, first of all, I love Rasmussen. He's my hero. I feel like I'm a disciple of Rasmussen. But he didn't have a really model. He was getting there. I don't think he's as familiar with systems theory as he might be. At the time, it wasn't that well known. And but he thought that way, and his writings are wonderful, but he doesn't really have an accident model. And if you look at what he wrote, or looks like a model, he's still got the chain of events at the bottom, and the fact, and that underlies axiomat. It doesn't quite go far enough. So what I did was take what Rasmussen did and just extend it and give a real theoretical, mathematical, foundation to it. It seems like in systems which include human interaction, the human should be modeled as a control element. Yes, no, absolutely. Absolutely. We always have humans in our control elements in our models. The OODA is directly related, voids the model, the cybernetics equals control. Yes, I mean, they're all based on control theory. Systems theory is a basis for control theory. So systems thinking in general includes control theory. If you look at what I wrote in chapter 3 of Engineering a Safer World, where I describe informally what systems theory is, you'll see that. It's a patient part of it. For drugs, has patient been a check on the loop for medication? I think it's pretty unfair to put the patient in the loop here. This patient was on a machine, external heart, before while waiting for a heart. And these are patients who are really sick. I don't think it's fair to ask the patient to know anything about what medication they're getting. How do they know what medication they're getting? Supposed to get? They're not trained in medicine. So saying the patient here, they suggest they should sign off before being put under. I was not ready to sign off. If someone, when I had surgery, I had some surgery, and if someone asked me to sign off that the doctors had done the right thing and given me the right medication, I would have torn off my gown and run out of the hospital. I don't want to do that. Not my problem, not my expertise. Or there's some delay. What's the delay in the recordings? As I said, the delay is just that John has to edit some of those. So we've got to get a lot of the editing and pauses. other things out of it. And then we've got to get them to the captioning company, and they can only do so much. It takes them like 12 hours for one session or something. I don't remember what it was, but it's about a length of time. So we'll get them as fast as we can. Nancy, most of healthcare processes have never been designed, so eventually there will be many adverse events. What are your thoughts on this? Yep. See, doctors, and rightly so, they're not engineers. They don't think they shouldn't think like engineers. They're taught to treat patients, but we don't have people working in hospitals and enough in healthcare who are trained as engineers and understand design and designing things using good engineering principle. I believe that healthcare needs to be that much of the healthcare needs to be engineered better, and it would be great if it was. But doctors are a little skeptical. I do work with doctors. And some of them get it, just not enough. Oh, Wallace, I see a message from you. I'll give you a plug. You and Lawrence both have a session on healthcare safety and use of it in use of CAST in healthcare events, adverse events. So you should, all of you who are interested in writing these comments should listen to, sign and log in. Make sure you log into their session. Oh, Wallace wrote, interesting to hear your comments on EHR. My latest CAST investigation is heading towards major EHR issues. Oh, definitely. The EHR is, I'm not against electronic health records. They should just be done better. We shouldn't have rushed into it. We shouldn't have forced people to buy these things from companies, no matter what the companies were putting out. There's been basically there was pretty much of a monopoly by one company. Now there's a couple companies, but there's still mostly one company. They make hospitals sign horrible non-disclosure agreements. Something's got to be done about EHR, and don't get me. Someone wrote, "Don't get me started on design and safety assessments." Gore. Yeah, it is awful. But we could do it. We did it. I mean, this nurse in the Netherlands with no training, no nothing in CAST or stamp or anything. He just did it on his own. He read the papers. He did this really. He sent me and I helped with a few points, improve a little bit. But he's done a great job on CAST on an SPPA of pharmacy order entry and pharmacy and hospitals. But it was all for nothing. From Philips, the new EHR from Philips. The same mistake. Oh, it's interesting. Here's one. Hi, Nancy. My hospital is currently introducing the EHR from Philips, redesigning the software from the ground up. All right, starts out pretty optimistic. I'm watching in horror as they simply repeat the mistakes made overseas. Any questions are simply repressed, objectors threatened. Interesting to hear about your nurse in Europe. Yes, this is standard. There's a really good guy, I can't think of his name right now, the University of Pennsylvania he's a sociologist who works in the medical school at UPenn. And he and I lamented this when I was still trying to do something about it. Still optimistic about 10 years ago. He's still in it. I gave up. The problem is that they don't understand. They need to get doctors who understand how they should be doing things. Doctors and nurses, sorry, they need to get healthcare professionals involved in the design of these things. We do that with aircraft and other things. We have pilots involved in the design of aircraft, and there's just no reason to not do it. We could do a much better job. Basic system engineering I teach is get the users, air traffic control that I've been involved in stuff, get the users involved at the very beginning, the concept development stage, and design this thing to assist them, not take over their job. All electronics should be, and information systems should be an assistant to a person. And we don't train. I used to be in a computer science department. I left, and again, I couldn't take it. But we don't train software engineers or others in human factors. There are almost, even in MIT, there's almost no human factors classes. There's few in our department in aerospace engineering, because aerospace engineering has understood how important it is, but not in the other engineering departments. So even the engineers are having the same problem. Can these approaches be, this is an interesting question, can these approaches be baked into the legal system, as in why weren't they done? Could the system be turned around to require them as some sort of standard approach? That's always been my argument to lawyers. I go in, this has happened for 20 years. I go in, I teach a class on how people can build better, say, medical devices, safer ones, and cars. And the students love the class. At the end of the week, they say, Nancy, it's great, but our management will never let us do this. Our lawyers will never let us. I said, what? What do you mean they won't let you do it? They said, well, the lawyers say everything, any hazard analysis and any analysis done on safety is deposable. And if there's an accident, it will be deposed, and the opposing lawyer is going to argue that we knew about the hazard, so we should have done something about it. And I said, that's an absurd argument. I mean, if I were a judge or on a jury, I'd be more inclined to be sympathetic to the company if it looks like they knew, had made an effort to make the thing safe. Sometimes things don't work out, and sometimes they can't be done, but they made an effort, rather than they just ignored it and didn't even try. But lawyers don't seem to feel that are my arguments holds. I don't know. They know more about law than I do. All right.
When we're ready
Chip
anytime.
and Lawrence, you're out of time. If you're not,
Yeah, we're ready.
You're ready?
Sure. Yeah, we've been just setting up some stuff in the background, just sorting out the best ways to do things, but I think that we're ready to go. So what we were going to do was something a little bit different. We didn't set up any slides. We're going to have the attendees essentially create the work as we go. So it's going to be a little bit different of an exercise. And the scenario will we'll see how much time we have. We're going to start with a pretty simple one that, regardless of your industry, you can understand. And that is, actually another one just happened about 2 days ago, I saw on the news, but passengers getting injured by not having seatbelts fastened in turbulence. And so these happen regularly. We have people flying along, the aircraft hits turbulence, and an accident occurs. So the first question would be, and we'll have set up a poll for this, which should be about ready to go.
It's ready.
Finish. Okay, we'll go ahead and launch it. And the question is, what do you think caused the accident? In this case, passenger injuries or death in some of these cases, and how would you prevent that in the future? And this is just sort of a demonstration to see how you normally would solve an accident. You know, if you come up on an accident or a scene without a particularly formal method, then what kind of answers you come up with and how this works. And this is really pretty similar to the way accidents generally are investigated, actually. So we can go ahead and generate that. We're getting a lot of good answers. People not, and we have a lot of really, I think, good answers. The poll, if you're not seeing it, look for a cast 2-3, and it's in Slido. The Slido is cast 2-3. I just picked it because it's the 23rd, at least in this time zone, for a little while longer. So we have a lot of good answers. So let's go ahead and model this as a cast. So the first thing that we do is you come up with proximate events, which at this point I think are fairly straightforward. And so if you were to list proximate events, let's go ahead and create another poll, just listing the proximate events that you think would be best to identify. And this would be just an airplane flying along, hits turbulence. There's not a whole lot to this. But what would be the events that would pop up in your mind?
Great. Just got another poll up, and it's asking what is a proximal event. It's another word cloud that everybody can participate.
Are we supposed to be seeing?
Yeah, and there is a blank screen right now because I'm using a whiteboard, just so no one's shocked. We're going to come up with that, and we'll be fixing that in a minute. So, all right.
Are we supposed to be seeing something?
Yeah.
I don't see anything. But
well, there's two things going on. There's in a poll, and people are answering questions in the poll.
Oh, I do see proximate events up on the right.
Yeah, so I just put proximate events. So people came up with a number of very simple things, and so the people who are attending can see that. I think, John, actually, you could probably find a way to, what's the best way to share that?
Share what?
Well, I'm going to see if I can share the results of the...
Yeah, go to present mode at the top, and you can share that screen.
All right. Let's see if your event is ready. I guess I can probably just choose which screen I share. If I can find it. Aha. All right, I'll try sharing this screen for a minute. And so these are the proximate events that people are listing. Obviously, turbulence is a big one. And so coming back to the whiteboard, what I'm going to do is just list. So we have proximate events, and I think people have identified. We have, of course, flying along, turbulence encounter, and we have possibly seatbelt sign turned off. Likely, possibly not using a seatbelt. We have using a restroom. A lot of other possible causes here. So the way that we would structure this is we really just start with a control structure, and the bottom of the control structure would be your physical components. And in this case, physical components, actually, let's just go ahead and start the something for that. We can just say, what would the physical components be in this case?
Yep, it's coming right up and done.
So what physical components do you see as the bottom? Okay, a seatbelt, and I think everyone is probably going to agree that seatbelt is definitely the bottom of this control structure here. So so I'm going to start at the bottom, and we're just going to build a basic one. We're going to start out with seatbelt. And before we even get, we can work our way through this. So above seatbelt, we have the basic component, and then we say, okay, so what is controlling the seatbelt? So let's move one above that. What's controlling the seatbelt in this case? See if we have another poll. And I'll get ready right here.
Yep. Okay, I see a lot of people are saying passenger in the word cloud.
Yeah, right, passenger. So, and I think we'd all probably agree the passenger is definitely in the control of the seatbelt, probably. So it's a baby. And then who is controlling the passenger?
Okay, there are some interesting answers coming in as well.
Right, we see, okay, flight attendant, pilot. Of course, it depends on the airplane size, whether the pilot has direct control. I think most of the answers are saying the flight attendant. So in the airline, the person going up and down the aisle, making sure people are complying with the seatbelt, it would be the flight attendant. So just move up from there. And then who would be controlling the flight attendant? I think everyone is agreeing with that the pilot or the flight crew. We'll just put pilot to make it easy. And then how about above the pilot? Do we have anything that we would look at above the pilot? So we have, weather itself is not a control because we can't control it. So, but what we have designed into our system to control the pilots and how they act. And definitely have a few things here now because I see airline procedures.
ETC is a big one on the word cloud.
Yeah, we're going to have ATC, which is actually going to be a separate item. So we're going to kind of branch it out here now. So we have policies, we have ATC, regulations, a lot of ATC, meteorologists possibly, which are going to be playing a part in all of this. Obviously, we have regulators, and of course, we can go above regulators as well, depending on how far we want to go with this, onto who is influencing the regulators. So we'll stop here. Let's go back to the seatbelt. And so one of the things that we need to look at and is the physical aspects of the seatbelt itself. Does the seatbelt itself have any physical problems? And so we can probably, Lawrence, do a new poll of what type of physical problems you might see in a seatbelt itself that could contribute to an accident.
It is coming up.
And I'm going to try to create a
So just a quick comment for everybody that is participating. Think about the physical aspect. So in the real world, okay? And I understand, I see some words about the interactional aspect about usability and things like that, but let's stay with the physical side of things for now.
Right, we're getting some good ones that, Lawrence, if you want to go through and read off any that highlight to you as you're looking at them.
There are some that are saying it can be wear and tear, broken, in other words. And some of the answers include jammed seatbelts, I guess, like associated with the buckles and things like that. It can be too loose, in a sense, I guess.
So we have a whole number of issues. So, and I'm not going to list them all out here because there's too many. We have a lot of really good ones, actually, I think. I wonder if there's a good way to, I'm just going to copy a whole slew of them. Let's see if this doesn't make a whole mess here. What does that do? Oh, that worked. So a couple of these, like, yeah, I definitely thought, problems with the buckle, the fitting. I mean, I've actually seen seatbelts that weren't actually, they accidentally did not attach them to the seat, which of course is going to give you a pretty bad day. Now, some of these other ones, you start getting into like differences from cars, that's a separate problem. That's now getting into the usability. So if we start making, let's take a look at, so we have the control from the passenger to the seatbelt. So let's look at this one control and why might the passenger not have been able to fasten the seatbelt? What could have gone wrong on the passenger control, attempt to control the seatbelt? So we can just go ahead and do a poll with that one. And see what would happen if you...
So there is a question that just put up, what might have gone wrong with the passenger's use of seatbelt?
So we have not aware, disability. So these are, yeah, these are actually really good. We have a lot of see any that jump out at you, Lawrence?
So I think the central theme here is at least we can identify the control action being the use of the seatbelt. So I think the fastening or not is of importance here.
Here's a few that answers that I'll just pop up here on the whiteboard. Let's see if I can get rid of this. I don't know if I can. So we have quite a few here, as you can see. And that just goes into that side of it. And so already we can start to identify problems that we can fix. And that is one of the real differences that I have found using CAS, is that very, very quickly we can start coming up with identifying problems both in the mechanical aspects of the seatbelt, as well as all of these different issues that we've already identified, that if you look at any of these reports on these types of injuries, really none of these have been addressed. Now we have another side here. Let's look at the passenger feedback that the seatbelt is fastened. And let's go ahead and see a poll. Why might the passenger think the seatbelt is fastened and not have done it? So we have some great answers of why the passenger might not have thought it. And don't forget, there's other things such as the passenger might have not been aware that that they needed to fasten the seatbelt. They might have been trying to sleep. There's a number of other reasons why they might not have fastened it for the down arrow side. But then we also have why might they, this is now a feedback side. Why might they believe it was fastened when it wasn't? And looks fastened, I think probably we've all had a case where we pushed a seatbelt together and it hadn't quite gotten into the latch. That's definitely a possibility. And so now that still comes back to a design issue, by the way.
And I think there are cases also where when you consciously fasten your seatbelt, let's say during the, I guess, pre-takeoff announcement and whatnot, the seatbelt did fasten, but for whatever reason over the course of the flight, like there's a small bump or whatever, the buckle just comes loose. So that doesn't necessarily update your mental model anymore, right?
Right. And again, what we're looking for is situations where we're trying to understand why it made sense for the person to do what they did. And in this case, you can see a lot of examples. Now, sleeping would be on the down, control side, but on the feedback side, you have a lot of possible reasons why they might have thought it was fastened and it wasn't. And it could be just as simple as that the design was such that it made a little bit of a click when they pushed it together, which some of these do, or something like that. So we've already now identified a whole lot of possible reasons why we might have gotten to this point here. And we haven't even gone past this passenger yet. We still have, of course, quite a bit more. So, let's see, I didn't mean to do that. So, so that was the feedback. So the next, above the passenger, we can take a look at the flight attendant. And so the flight attendant is a control for the passenger. So what reasons might the flight attendant have exercised this control? If we look at this down arrow, I don't know how you want to phrase the question, Lawrence, but something creative.
Let's see. Why don't we start with the question of what is the control action that flight attendant can exercise over the passenger first?
Oh, that's a good way to put it, because the role of the flight attendant is to exercise the control. And by the way, when you're doing a CAS, we would be listing, as soon as we identified all of the items and the approximate events, and then the control structure, we'd be listing the role, and we write out specifically the role of each of these in the safety control structure.
Okay, so I see quite some interesting answers there. There are things around instruction, announcements, and things like that. But one, I guess, suggestion here is all those are avenues that the flight attendant is trying to achieve something, trying to exercise this control action. But the biggest word that I'm not seeing is what I have in mind as far as the control action is concerned. So think a little bit about what do you want to command that passenger to do? And command may be too strong of a word here, but think along those lines.
Unless there are a couple airlines where it's somewhat of an imperative.
Okay, I do see some answers coming up here around fasten seatbelts, around put on seatbelts and things like that.
And I think we also saw, visual check, how the flight attendants exercise that control. So then along with this, and I'll go ahead and add it now, this is kind of obvious, is what is the feedback the flight attendant depends on to make sure that job was done? What does the flight attendant need to do to make sure? So here's the next question, would be, why might that feedback not work? And to a certain extent, this is, in a cast, we would already possibly know the answer. So I suppose this is borderline on a kind of an STPA type of question, but it's still, I think, a good exercise.
So yeah, just to take a step back, right? I'm seeing a lot of answers on the feedback that the flight attendant receives. They involve like visual check. Somebody suggests even giving a tug on a seat belt, to see whether it's fastened or not. So now the next question is coming up. Why might this kind of feedback not work as in an actual incident, presuming that, we're analyzing, right?
We got some. We did have one for CAT, clear, turbulence, surprise, but that would be one level up. The flight attendant has no way to control that.
I think the seatbelt not being visible is a big theme that a lot of people are putting in.
It really is. And so this might be a time, we can, normally we'd work through all of these and then you work on recommendations. And just to keep it so we're in the frame of mind of each point, it might be interesting just to look at what possible recommendations we could have made just for these first three boxes. And it's, again, it's, when you're doing the whole thing, you're writing it all out and then you work back and come back in, but for recommendations. But I found it useful when writing up a few of these to actually start listing recommendations when I was really still deep working on that particular section. And there's really no one way to do this, by the way. I know people have talked about using computer programs for this. I find that just freehand tends to be the easiest for me, but everyone has what works best. But if we look at each of these in terms of recommendations, and we'll work up beyond this in a minute, let's go back and maybe Lawrence create a poll of what recommendations could we make for the seatbelt. that would make this so it would be less likely to occur.
Yep, it's right up.
And we'll start with the seat belt, and then yeah, see, these are really good. You know, and one of the issues, of course, is historically with airlines is trying to save weight. You know, in the auto industry, you can add in feedback, or on amusement park rides that you know that the seatbelt's fasten, but obviously that adds weight to an aircraft. Although I would think as technology is improved with some of these piezoelectric sensors, that we might be able to do something here that was pretty lightweight. I'm not double E person, so I'm not probably, so I might be missing something, but maybe a double E person could chime in and say what they think. Is it light enough? Could it be done? Because if you had some type of feedback to the flight attendant where they knew where seatbelts were fastened or not, that would be a huge difference. Obviously, we have mechanical checking. I saw some people talking about inspections of the seatbelt to make sure they're really working. I don't know how often that's really done. I don't know whether maintenance does a lot of things, but unless somebody reports a broken seatbelt, do they actually go and check them periodically? And I think not, quite honestly. If somebody in the aerospace industry knows otherwise, I'd be curious, but I've never seen anybody doing anything if they... I
think we're getting some feedback from the chat that in Europe it does.
Yeah, that's interesting. Cost and maintenance are the issues with seatbelt indication. Yeah, that makes a lot of sense. So if we can improve the feedback for the flight attendants, we start really enabling something. Now here's another factor. So the passenger, reasons that they might have not fastened their seatbelt in the first place could be as simple as they were just trying to sleep, or they were trying to be relaxed, or they went back and they sat down. Now all of the airlines do have an announcement that they make when turning off the seatbelt to remind people that, to keep them fastened while en route. But when there's no turbulence and the seatbelt sign is not on, and you're in a long cruise, particularly on longer international flights, I have not seen anybody walk through the aisle and just say to the passengers, hey, your seatbelt isn't fastened, buckle it. And that might make a pretty big difference. If somebody has any indication of any flight attendants telling somebody to fasten their seatbelt when in cruise without the seatbelt sign being on, I know most airlines don't do that, and I do ride in the back quite a bit, as well as in the front on a lot of different airlines. And I've never had anyone say that. So that might be a simple control the flight attendants could exercise to improve the situation. And that comes to mind just looking at the controls.
I know we're sort of out of sequence here, but I would interject here to think that if an actual incident does take place here, then a question to probe around what you just said is, okay, what is the culture of the airline? Would that support this kind of proactive action, or does that inhibit that kind of proactive action? Obviously, some passengers might come back and say, hey, the seatbelt sign is not on. Why do I really need to do it? This is poor passenger service. They might actually complain, and it can cascade, and so on and so forth. So that might actually probe for a question of, how is the company culture, safety culture? How does that balance with your passenger appeal and so on and so forth?
Yeah, exactly. So moving up one level now to where some people started, if we go to the pilot, what is the pilot's control to the flight attendant to have them fasten the seatbelts? and why might that not have worked? I'm going to see if I can. See if I can just make a couple items here and we can see if this will work. So obviously we have, their big one would be announcements. And as an aside, while looking at this, so the pilots will make announcements to the flight attendants. Another big issue, which we're not looking at in this particular case, but would be an interesting one to look at, is flight attendant injuries, which happen a lot. They're not buckled up. And to what extent is this control working to keep flight attendants safe? And just something to kind of think about, because that is another area that we could really probably reduce those injuries quite a bit. So we have announcements, seatbelt sign. So seatbelt sign is actually a physical component. What could go wrong with the seatbelt sign? And what could go wrong with the announcements? So here's a good question, is why the seatbelt sign might not have worked and why the announcement might not have worked. I'm guessing that everybody here has been on an airplane where you couldn't understand a word the pilots were saying over the PA system for whatever reason. This is a very, very common problem. And I don't know to the extent that these have been investigated on actual events. When I've read them, they don't seem to talk about them much.
I think the really interesting aspect that just occurred here is obviously we get a lot of answers on the Slido, I guess, platform on things like failure, like the speaker doesn't work, the light doesn't work, and so on and so forth. What you just mentioned about the language aspect, that is something that is a non-failure causal factor, right? Like that is really an interactional side of things, which is much more interesting.
Yeah, I'm seeing some interesting in the chat too. Now, one of the questions we have is, are we talking about a sudden CAT upset or an event where a pilot has sufficient time to decide when to turn the seatbelt sign? Absolutely true. That's and these events vary. Sometimes there are one of either. And so we haven't even gotten up that far, but those are really valid questions to look at in the particular context. And if it's and that starts getting into what kind of feedback the pilot has to make those decisions. And so that's a little bit further up the control chain. I think discrete communication link between a seated flight attendant and passenger with indicator screen for all passengers. I think that'd be a beautiful solution if we can figure out a way to keep the weight down and maintenance down, which I think should be much more possible with today's technology than it was 20 years ago. And then, yeah, low level of intelligence with passengers. Yeah, passengers are, as an aside, I'm just amazed to see people riding around in the back of airplanes wearing, flip-flop sandals and shorts and whatnot, thinking of what would happen if they ever had to evacuate in that. So you have the pilot on a down arrow. Now, if we go to the next, we can look at what kind of feedback the pilots have that things have been done. They're flying along, they're about to encounter some kind of area of turbulence. What kind of feedback are they depending on before continuing? And do they have the option even to do something different? Actually, sometimes they do, but sometimes not. So the next question is, what kind of feedback is the pilot depending on here? Yeah, we got some really, yeah, in some cases, they may not be waiting for any. I mean, all they can do is they can only exercise the control, and the feedback may or may not influence what they are going to do next. Are they really going to go into a holding pattern at altitude? If the flight attendant says someone isn't seated, it's not like they're sitting on the ground and they can set the brake. A good observation. Crew are generally less willing to make directives to higher value customers, especially when the seatbelt sign is off. So this is another area, and this is, of course, is above the pay grade of the pilots. So now we start getting into areas that are in control of the airline. And so the question is why the pilot might have made the decision and what they're depending on. And as you can see, we're going to start ending up with several aspects that are feeding down to the pilot that can affect their decision making. And so one of them, of course, what's their feedback that they have on weather, right? I mean, I know people put that in the beginning and earlier on, but this is not I shouldn't really write it that way, actually. Undo that. It's really trying to think of the best way to put this. It would really be the information that the crew has. And
so along the lines of maybe the meteorological information from
yeah,
dispatch, or it could be weather information coming up.
yeah,
from
it could be like onboard radar. So they have radar and basically displays, which obviously have their own set of issues. But it's starting with policies and procedures. What type of policies and procedures might influence this, and what could we do about them? What kind of recommendations might we come up with as far as when the decision making of how the pilot exercises that control? I keep thinking that I can, speaking of control, move these boxes around like I'm in PowerPoint, but apparently not. So we have a lot of good answers here. See anything, Lawrence, that pops out at you?
I think so. There are definitely safety policies, and then there are some additional ones on operational policies, right? And obviously, the two can interact and can conflict, and those are the interesting aspects, I think.
Yeah, definitely so. And so we have difference, and we have some people saying FAA, that's a regulator, they're still above all of these things. And of course, above the regulator, you have the politicians that try to avoid funding the regulator, which is a huge problem, by the way, around the world that I've seen. The regulators are notoriously underfunded. So a lot of instructions. I'll mention one of these, of course, policies and procedures would be how to, and that would also fall under training. We can include training in that same box, I think. This is really the airline box here. So we have policies and then radar displays. So, this is really the manufacturing box, the OEM box, you could say. And then here, this would be technically the operator, obviously. And so part of the training is training the pilots to understand their displays of the radar and what they're seeing. Do you think do we have anything that could go wrong in the training side?
Did you want to pull on that, Shen?
Yeah, sure. Let's.
It is not explicitly related to our current incident as far as the in-flight turbulence kind of injury incident, right? But then obviously airline training aspect is heavily looked at right now in the recent events kind of situation.
Yes.
While the results come in, I guess I will make a small suggestion on the safety control structure. So
Yeah.
I think obviously, as you identified here, the OEM basically designs the aircraft, right? And the
Yeah.
radar and the display is part of the aircraft. So what about we add an extra box maybe at the bottom that is the aircraft itself, I guess, and then we can probably sort of, we can designate the radar and the display there, and obviously that would have a feedback to the pilots as far as the weather and whatnot.
Yeah, good idea. So we have the aircraft at the bottom. Of course, the seatbelt is not feeding down to the aircraft exactly, right? So I'm not sure that that would work exactly.
Oh, sorry, I meant we can put the aircraft side by side with the seatbelt.
Oh, okay.
And,
well, I would do that if I could move. I'll undo it.
And we would have the aircraft provide a feedback to the pilot on the weather side of things. So it would be the weather information that is being fed back to the pilot. And obviously the pilot would control the aircraft. However detailed we want to go through here as far as the control action, we can just do, you know, directional and thrust and so on and so forth.
So one thing that is actually worthwhile to think, I'm going to move this actually a little bit more. I have to undo it to do it. But when we have done these, we have found that we actually are better off, rather than try to put it all into one stack and connect everything, but actually create a different hierarchy. So you might have one that is for the aircraft, and of course the regulator is coming down to the OEM, and the OEM is going down to the aircraft. And of course they also have vendors, for example, you know, like Honeywell or Collins, for example, for radar units, etc. But in that way, we actually have a separate structure of the aircraft and the design of the aircraft. In the one we did for one of the accidents, we actually had another separate control structure for the airport authority and the design of the airport and the structure. And each of these are operating independently, contributing to the accident. And then at the end of this, we go to the top and we look at the problems across that basically span all three of them, and the various feedback, the changes over time, things of that nature that affect all of them together. And so that becomes a much more powerful way to do it, and a lot simpler to think about it, because if you start mapping all these together, you end up with arrows everywhere and it becomes easier to get lost. It's what we, you know, at least what I found in some of these. So we actually have the say the aircraft here, and the radar displays and all that obviously would be part of that. And what I might do, figure out a good way to actually, I think I have a way to do this. I'm going to just show control structure that we use for a UPS accident. And so let me switch screens for a second here. And so we can just get some way of, let's see if I can find it here. Oh, there it is. All right, so if you can see, this is for a UPS accident, and we had the airport structure on one side, and then of course, the airline, which is controlling down to the aircraft, and then we have the OEM on the right. And somewhat similar, separately, we have the, sorry, I didn't mean to hit that, have the Independent Pilots Association, which was their union there. And so we worked through each of these sections independently, and then we pulled them together at the end. And this paper is on the website, actually, so you can see it. But towards the end, we end up with problems that span all the system components. So we have industry and organizational safety culture, dynamics changes over time, communications and coordination amongst controllers, and the safety information system. So we actually pull those together afterwards. So if that, I don't know if that was helpful for everybody, but this gives you some idea of a better way to structure this possibly. All right, so, so we had some good examples on training of what could go wrong. Now, how about the feedback from the pilots back up to the, let's start with even the operator or to the airline. Where could there be problems here? To start another poll here of why the airline may not have had the feedback that there was a problem. And let me ask another question that relates to this. That I see a couple no reported incidents. How common do you, or what is the criteria that people use to report incidents currently? And this is for those familiar with the reporting that most of the companies are using. What reasons might people not report? Well, some really great answers popping up. Pressure not understood, fear of losing jobs. How often do you think people encounter an event and fix it and then go on about their business and don't bother reporting it, just attributing it to their own error? That would be a related question, I think.
Yeah, so what you identify is, I think in healthcare, some people call it fix and forget kind of mentality, and definitely very common in healthcare.
Yeah, it's very common in the airlines as well. You wonder how many of these events people just said, you know, just noticed something and then they undid it. I kind of wonder about that for the, actually the Atlas accident, how if people had inadvertently triggered the go-around mode previously and just caught it, you know, or well, we know that's happened actually. The question is how much. So these are the kind of things. Oh, passengers rushing to connection. That actually is an interesting pressure that goes on the pilots. You know, what kind of pressure does a pilot have to continue through the weather? That actually was a very interesting comment that someone just made. Label it as troublemaker. I think some great answers here. Do you have any thoughts, anything else, Lawrence, to add? Or
I think so far all the thoughts are amazing. Just to clarify, did you want a poll question on what is a criterion for people to report incidents, or are we sort of flying?
Well, I think people are answering it right here on the feedback. I mean, from the pilot to the airline. So I think people have already answered. I see some great answers. So one is saying human error, which is kind of a catch-all. Like, really we need to understand it, just like lots of situational awareness of why that happened, not just that it did happen. Just identifying it doesn't go far enough. But we need to understand, why did it make sense for people to do what they did? I think it's a very interesting aspect. And then we have another aspect here, and this is definitely affecting the pilots, which is ATC. So take a look at ATC, and why might they're exercise the control? Why might ATC have not exercised the control in this case? Interesting comment from the maritime industry. Safety stats are leveraged as a form of competition, making it commercially impractical to report incidents through the available mechanisms. I don't think that's just the maritime industry, unfortunately. Yeah, conflict with TCAS could do it. Not aware of the weather is certainly an issue. In a lot of the world, the U.S. controllers try to steer aircraft around weather. That's not true in most of the world. So, or varying degrees. So one of the areas that's putting pressure on the pilot to make a decision could be air traffic control. I know from my own experience, for example, flying, threading between restricted areas in China, that there are times where there really isn't an alternative but to penetrate some weather, unfortunately. And that's, I think, what happened to a couple of these hail encounters that happened. I think it was Delta Airlines a couple of years ago. But the other, that's a separate issue, because lack of training and lack of understanding of what's being displayed on the radar is a separate issue that goes down from the other side here. And along with that, what is the feedback that the pilot gets from the pilot back to air traffic control? And then looking at both of these loops, what kind of recommendations might we be able to generate to improve the situation for the future? So a question is, how do you model production pressure in a control system model? We already kind of touched at that. Lawrence, do you want to hit that one? Because production pressure definitely hits the medical field as well.
Yeah, so production pressure, I think how I would say is that in my mind, I tend to find this kind of issue in part 4 of a CAS analysis. So in part 4 of a CAS analysis, you're looking at what kind of systemic factors that impact many, if not the entire control structure. And I think in many cases, production pressure tends to come into play then. So in that sense, I would, if you're, to answer your question explicitly of how do I model it in a control system model, I can put in a sideway arrow to pop it into a controller and mention that as a factor. And then you can do that in the individual controller analysis kind of stage. But then it is even more pronounced when you take a step back in part 4 of a CAS analysis. And then you tend to find that, oh, this kind of, this factor actually impact multiple controllers. And that makes for really, I guess, pronounced pattern recognition to say that, oh, wow, that kind of competitive pressure is a systemic factor, which is very commonly the case, as Shen mentioned.
Yeah, we actually saw just a couple comments earlier about the pilots possibly under pressure to make sure passengers made connections, by the way. And that would be right under the pilot, right there. Flight attendants are under considerable production pressure in order to continue service. And we're not looking at flight attendant injury in this particular case, but the flight attendants, if they're not given a directive to sit down by the pilots, they might say, we might be counting some turbulence. The flight attendants will tend to continue service. And that's often been the situation where injuries occur. So it's, so that definitely is some production pressure as well. So you can see it hitting different levels when you're trying to understand the contextual factors of why it made sense for the individual to do what they did at the time, or why something might have been missed. It starts popping out up and down. And actually, even in the maintenance of the seatbelts, there's another area of production pressure. How much time are they allotted for them to check 300 seatbelts? Or are they even doing so? Apparently in Europe they are. So these are all areas that I think could be really looked at. And so another aspect in the feedback from the pilot to air traffic control, I see that there's quite a bit of good feedback coming back. One of the things is it possible for air traffic control to have incorrect feedback from the pilots in terms of where the weather is or what's going on with weather? This might be a good kind of question just to think about, because when we look at feedback, we have to look at why might that feedback be wrong. And we really do this at each stage. Again, we're really doing we're condensing into an hour and a half, something that, to do properly would take a couple of days anyway. But just to make it an exercise so you can kind of see how this would work.
So I just posted a question on why would air traffic control provide incorrect input to pilot on where the weather is, just to be sure that is the question that we want to think about, right?
Yeah, and then a related question, I don't know if you want to do a new poll, why might the pilot be reporting something inaccurately to air traffic control? And by the way, this happens a lot. Yeah, we have incorrect PIREPs. So this is, that's a really accurate one. So we have pilot reported something and air traffic control is issuing clearances based on that pilot report. And those people in aviation are probably aware of how bad pilot reports can be. And of course, how quickly they date themselves. Pilot's drunk. Hopefully that's not. Yeah, poor radar or inaccurate. And just as anecdotal example, I've had controllers tend to report weather in the United States, but they're not really paying attention to the altitudes that weather is. So low altitude rain will be reported as extreme weather in front of them. Then the pilots report back, no, there's nothing here because they're way above it. And now the air traffic controller maybe even begins to lose trust in their own system. And in fact, I know that air traffic controllers don't trust their own system to depict weather, and this is part of the problem. Yeah, clear air turbulence is an ongoing issue, although we're getting better at forecasting it. But the question is, how much do people trust it? So we kind of touched on the OEM and the radar displays. We could move up through the regulators, or which direction do you think? You have any thoughts, Lawrence?
I defer to you.
We can go either direction. It just depends on, I'm just looking at trying to keep it constrained in time so we have some extra time at the end to look at some, quickly look at maybe another example, but not obviously be able to go through each layer like this. And you had one, right, Lawrence? Something you wanted to talk about?
I have materials prepared, but that is only if we have extra time. So
all right. Well, I'm just going to go a little bit further because I think it would be worthwhile just so you can show another example. And mainly this is just to give people a good, a sense of how to run this. We'll run up to the regulator. Someone just wrote, turbulence occur every day and seem to be a cost of doing business, which certainly is, shouldn't be true. I don't know how else to say that. So if you look at the regulator, where might the regulator, let's just try a feedback here, and we'll just look at the down of what controls is the regulator exercising over all of these. That might, or what control should be what they're doing, and why might they not be able to exercise those controls? I think we got some good answers at the beginning of this that would answer some of this. Here's an interesting question. What about when the seatbelt actually kills someone during or after an accident? Did we just inadvertently map the process to get someone killed? So the question is, so I would ask how that would occur. Like what would be an example of that? And so, because we'd have to look at that very specific event. Obviously, seatbelts prevent more deaths than they cause, but I do know that there have been cases, not as many as airbags. Whole other story. Yeah, so one of the things is the how they're influencing it, and if you look at why that control might not have worked from the regulator standpoint, what why would it not work? Why would the regulators' control over these policies and procedures have not prevented this accident? Because again, this is what we're trying to look is why the control in place did not work. And we're trying to understand it. And once we understand why they did not work, once we understand why the controls didn't work at each level, we can generate recommendations for how to fix them. And that's really what we're trying to do. Yeah, lobbying. I figured that was going to come up. And we know that that has been an issue. Yeah, the regulator is going to be over air traffic control, whether air traffic control is a privatized one or a government. But how are they going to be made up compliance, underfunded? And then similarly, if we look at the feedback, we have ATC feeding back. What kind of feedback is the regulator getting from these different organizations? And why might that feedback be inadequate? Because in order for them to properly regulate, they're going to have adequate feedback. And so there we have another related issue. And I'm just going to put the very top, the government. And I think we have a waste of time feeling a lot of siloing. Those who work with FAA, especially the people within FAA, are very aware of the siloing within the organization. Really, I know, a constant source of frustration. So we have quite a few aspects, and we can and obviously, if you look at each of these, we can think of ways that we can mitigate these. We can come up with recommendations, and that's really the point of this. And as Nancy said, the complaint that we've had is too many recommendations. You can generate a lot of recommendations with these, the things that need to be fixed, and it easily captures all of the traditional items, and then we end up with, you can end up with a huge amount that we've tried to pull down into, shorten to the extent possible, but it really isn't that possible to get them that much shorter. And then finally, and again, we can pull in a lot more at each of these stages, and we're trying to keep this a little bit shorter, but we have the government control over the regulators. Do we even want to ask the question of why that could not work? Might not be working. I guess we could pose it. It'll be entertaining.
As in, why?
Why does the government? Yeah, and then what? And the feedback from the regulator back to the government. Why might these two not provide the controls that we need?
That's going to be touchy.
Yeah, I don't think it's going to be that touchy. I think this is universal across the entire planet, as near as I can tell. I don't think that there's any government that is performing flawlessly on this regard, and I think everyone has the same complaints. So it's not a. Yeah. And if anybody knows of a country where this is not true, let me know. Because I think government in turn is under constraints. And we could actually model what are the controls on the government and why aren't those working? That's a whole other thing that might be maybe certainly interesting, if not, of course, probably really difficult to change. But government itself has a lot of pressures, and they have their own feedback mechanisms of how they change things. And this is a really flawed system around most of the world. So don't get me started. A great answer. Can we apply Snapcast to elections? Yes. You actually can. Yeah. And it's interesting. It's actually interesting to do so, but yeah, Twitter would be the control structure. That's really funny. So yes. So the answer to these questions, though, is really absolutely you can. We intentionally are not, for obvious reasons. So we have some really funny answers in the chat. So what I thought is we still have a few minutes. Do you have time to kind of talk about one of your things, Lawrence, real quick? Or is there not enough time?
Sure. Okay.
All right.
Yeah,
so why don't you take it?
Okay. I will switch gear. I will try and share screen.
And then we'll have time for Q&A and stuff afterwards.
Yep. Sounds good. So let me try and get the controls here.
Do I have to stop share, or does you do it? You just take it?
I will take it. Awesome. Okay. So just because of the interest of time, we are going to not go through the entire radiation therapy incident, but I guess what I would mention is that one of the things that I would like to achieve is actually to, let's see if I can do this. Okay, awesome. Recognize some of the common mistakes in stamp and cast concepts. I know in years past, Nancy and John run a really good presentation seminar on what to avoid. And since I did not see that on the agenda, I'm going to maybe take a page from them and try and go through some of these things. So let's do this. Let me try and go to this page here. Okay, great. So one of the things that we need to do in either a CAS or a STPA analysis is to define the losses and hazards, right? And just to remind everybody, hazard is defined as a system state or set of conditions that together with specific environmental conditions can lead to an accident or a loss, right? So some of the common mistakes when identifying hazards are having hazard statements that refer to individual components of a system, meaning that you are diving way too deep down into the system and naming individual parts, but rather than staying at the overall system or system state level kind of description. So that is actually bullet point number 2 here. Bullet point number 3 is that it would be a mistake if you have hazard statement that refer to factors that are not controllable by the system designer or operators. And lastly, it would not be great if your hazard statement has words such as unsafe, things that are not very much defined. So it's not more refined in terms of leading you down to a more structured and sophisticated analysis. So these are just some of the mistakes that, that can take place in your hazard definition statements. So let's do an exercise here. Let me go to the next slide. Just to get some feedback, Shem, my slides are coming through okay, right?
Yes. Yeah, they
awesome,
look good.
Great. So I do not have a Slido, and I do not want to burden Shem to make.
Yeah, you can do that.
Oh, okay. Would you mind making a poll of which of the following shows some common mistakes? So we can just do options A, B, or C, and it would be a multiple selection if possible.
All right, multiple
options.
Which of the following are common mistakes?
Yep. So let's see if I can go to the results there.
Let me just see if I can. I just have to hit. There we go. Should be up.
Awesome. So, okay, I do see many results coming in. What I'm looking for is not particularly pronounced, so I want to wait a little just to see if more people would select what I have in mind. So again, you just need to type in A, B, or C, or A, B, and C, and variation thereof. Okay, I do see more than 100 kind of entries, so I'm just gonna go ahead and move on. So what I have in mind is A, B, and C, and I'll explain to you why, and feel free to disagree with me, we can talk about it. So statement A here, it actually shows the first bullet point of mistake, right? Like we are, sorry, I should have explained to you what kind of situation we are dealing with here. That is my bad. I guess I haven't defined the system very well. So in that sense, that explains some of the situation here. But what we are dealing with is a radiation oncology kind of system, and a dosimetrist is a very much a frontline worker there. And so we don't want to focus our hazard statements on just the front line. And so in that sense, it has dived too much down into the weeds. And similarly, this also apply in the option B here, the linear accelerator is one equipment that is used in radiation oncology, and it is too much in the weeds if we use that as a hazard statement. Statement C is a situation that we have no control over. It may be something that we should keep in mind as to whether that had an impact on the incident, but to have that as a hazard statement for our system, that is not going to be very useful here. So now I have actually one additional Easter egg hidden in here. So let's go with a poll question of what is additionally wrong with statement A. Let's try and see if people can identify a little nugget that I hit there in statement A. What is wrong with the statement A? Just a sentence as it stands in the stamp kind of thinking. What is wrong with statement A here? We're not thinking it necessarily in terms of the context of a hazard statement. We're just taking this statement and thinking it with everything that Nancy said this morning, and she in fact emphasized it multiple times. So what is wrong with this sentence?
A lot of assigns blame and failed.
Okay, cool, awesome. This is great. So you guys got it. Sorry, I realized my last question was a bad setup. I didn't describe to the system and whatsoever to you, so that was my bad. But this question, you guys got it, absolutely. That is the problem with the word failed there. It just always lead to blame. And by identifying that somebody did not do an action, okay, notice my wording is somebody did not do an action rather than failed to do an action. We describe that action, and then we seek to understand the context of why that person did or did not do something. So that is a much more useful thinking than simply saying that somebody failed to do something. So just to reiterate what Nancy would say, a human doesn't fail unless somebody die and go into cardiac arrest or becomes incapacitated. So highly recommend you to throw that word out of your vocabulary when it comes to incident analysis and things like that.
Yeah. And by the way, Lauren, I didn't mention it earlier, but when we have been writing these up and we're mentioning a human or a component, we are listing, rather than an unsafe control action, we've changed it to contributory control action to take any form of blame out of the possible thinking.
Indeed. That is great. Okay, let me see what I can skip to and without creating too much unintended consequences. Okay, so, all right, let's do this one. It is another common mistake in your creation of control structure that people tend to label their control structure with specific implementation instead of a functional information. So what I mean by this is, for example, you have a safety control structure that, let's say, me as an operator, I need to pressurize a vessel. So in the downward arrow of control action, instead of listing pressurize as a control action, I'm listing a specific make and model of a particular pump. So how that control action is implemented rather than listing the control that I want to enforce, which is to pressurize, right? Okay, so that is one common mistake. Another common mistake is to have very ambiguous or vague labels, such as just having next to your arrows either command or feedback. This may be admissible when you're at a very early stage of a system. You have completely no idea about what you're going to build or very little information about what you're going to build. But this is not great when you actually have the information. So you actually want to be careful about what kind of labels you put next to your downward and upward arrows, or even sideways arrows and things like that. So the physical process is not controlled by one or more controllers is another case where we see safety control structure that is not great. So basically what this means is you have a box probably at the lower part of your safety control structure that is just dangling. It's not connected to any other controllers by arrows and things like that. And lastly, this is especially important for CAS analysis. if you define your safety control structure too narrowly, it really limit your perspective, limit your visibility. And so the causal factors that you identify are not going to be very comprehensive, and it may not lead to very effective safety interventions. So that is something that we want to avoid. So with that said, let's look at this very simple, I wouldn't even call it a safety control structure, right? It's just a two-box kind of control loop here. It has very minimal information. We have a treatment planner. Again, I'm not going to tell you the full story another time, but this treatment planner, the dosimetrist in this particular case, is going to control a treatment planning system. Now, in return, the treatment planning system does provide feedback. I have the feedback here labeled as a multi-sync E172M. I have no idea what that is. I just looked it up. It really doesn't associate with the case itself, but what it is physically is a LCD monitor, 17-inch. It is commercial display. It is supposedly a medical grade kind of monitor that produced very good definition on your MRI image, on your CT image, what have you. So I have that as my label to the upward arrow. What kind of common mistake does this control loop embody? Let's have another poll question on that if we can.
I got this one.
Oh, sweet. Thanks, John.
All right, we'll call it.
Okay, sounds good. So answer A is exactly right. So we have this monitor display here that is labeled, right? But then it actually doesn't necessarily tell you what kind of information is being fed to the controller. So what a better label could be the image. Okay, you can say image itself, or you can say CT or MRI and so on and so forth. And so that would be a much better label as compared to naming the model and the make of a particular implementation. So I do see that we're at 1:55. I don't know if we want to move on to anything else. I have other examples, but then they are probably more involved, and I am not sure we should spend the time on describing all the back end of the information. So I defer to Shem, John, and Nancy about what we want to do if we want to go into something else.
I'm good, or we can go into some Q&A if people want. You know, we intentionally picked something that was quick and truncated it at that. So, but it just, there's a lot to cover in a short period of time. There's no other, I don't know of another exercise that's quite as simple that everyone can understand regardless of industry.